Have you ever eaten a dish without salt? That bland, empty taste stays with you, long after you've forgotten 100 other delicious meals. Salt, often dismissed as a humble seasoning on the table, is, in reality, a strategic resource that has shaped trade, industry, and even history. Across every era, it's been the silent heartbeat behind a global food economy worth hundreds of billions of dollars. But how do we harvest over 100 million tons of sea salt every year and turn it into a core ingredient of modern civilization? That journey begins on vast, blinding white salt flats that stretch to the horizon, where nature and technology move in perfect harmony. From traditional salt pans to high-tech refining plants, each grain of salt undergoes a remarkable transformation, from raw seawater to purified mineral on your table, or even a critical ingredient in batteries, medicine, and key industries around the world. Today, join Agriculture Insight as we explore the spectacular world of sea salt, a world where every tiny crystal carries with it the weight of history, science, and the power to sustain human life. All of that and more is coming up in this video. China is currently the world's largest producer of salt, with an annual output of up to 70 million tons. With coastal salt fields spanning thousands of hectares, the United States ranks second, but leads in cutting-edge extraction technologies and advanced automation systems. Throughout history, salt has been far more than just a seasoning. It was once used as currency, a strategic weapon, and today remains a billion-dollar industry spanning continents. But have you ever wondered how salt is actually formed? Accounting for nearly 60% of global salt production, sea salt is the most common and accessible type. As seawater evaporates under the sun in shallow salt ponds, the salt concentration gradually increases until it reaches saturation, causing sodium chloride to crystallize into shimmering white layers that sparkle like crystal. An adult needs around 4 to 5 grams of salt per day to maintain blood pressure, nerve function, and internal balance. But when consumed in excess, salt becomes a silent killer, leading to high blood pressure, heart failure, kidney damage, and other serious complications. And now, join us as we begin the journey to the birthplace of salt, where sunlight, wind, and human hands come together to create the glistening white gold that has sustained civilizations for thousands of years. Every December, as the weather turns dry, sunny, and low in rainfall, ideal conditions for salt crystallization, the coastal salt farms begin a new production season. Farmers start by restoring the entire salt field system in preparation for the journey of harvesting white gold. Storage ponds, concentration ponds, and crystallization beds are thoroughly dredged, leveled, and reinforced with solid dikes to retain water. The pond bottoms are either paved with dark cement or compacted with clay to prevent seepage and enhance heat absorption, accelerating the evaporation process. A standard salt field system typically consists of 3 main zones: a settling pond to purify incoming seawater, a concentration pond to increase salinity, and a crystallization bed, where bright white salt crystals slowly take shape under the coastal sun and wind. Once the salt field system is ready, seawater is channeled into the first settling pond through shallow ground-level canals or pipelines connected directly to the sea. Each settling pond can hold up to 500,000 liters of water. Timing is crucial. Water must be drawn in during high tide to capture optimal salinity. A delay of just a few hours can disrupt the entire crystallization process that follows. There, it is held for 1 to 3 days to allow sediment, sand, algae, and plankton to settle, effectively purifying the water before it enters the crystallization stage. After this settling and filtration process, farmers use salinity meters to check whether the brine has reached the appropriate saturation level for salt to begin crystallizing. This precise measurement helps regulate the salt concentration, ensuring even formation and high-quality harvests. When the seawater reaches the desired salinity, it is channeled through small ditches into evaporation ponds, where natural sunlight and wind gradually evaporate the water. At the concentration pond, seawater continues to undergo natural evaporation under the combined effects of sunlight and coastal winds. As the water gradually evaporates, the salinity rises from an initial 3 to 5% to around 20 to 25%. This process can take anywhere from several days to over a week, depending on sunlight intensity, wind speed, and humidity. When the salt concentration reaches the optimal range of 24 to 26%, the brine is transferred to the crystallization beds, areas with wide, flat surfaces that are carefully treated with black cement or compacted clay to prevent seepage and maximize heat absorption. Here, the brine is maintained at a shallow depth of just 3 to 5 centimeters, an ideal level that allows sunlight and wind to penetrate effectively, accelerating evaporation in a consistent manner. After about 2 to 5 days, sodium chloride crystals begin to form from the bottom up, creating a bright, evenly grained layer of salt that's easy to harvest. Interestingly, the crystallization process doesn't occur as individual grains, but rather as thin sheets that can peel off in large flakes. In small-scale salt production areas, or regions where salt flats are uneven, with soft soil or sandy surfaces that limit the use of machinery, traditional manual harvesting remains the primary method. Simple tools like bamboo rakes, aluminum shovels, and hand-pulled carts become indispensable companions for salt farmers in their daily effort to collect the precious white gold. Salt is gathered into small piles, then loaded onto carts or specialized transport vehicles and moved to collection points in preparation for storage and distribution. The work demands endurance and precision, as it often takes place under intense sunlight, with the reflective surface of the salt field amplifying the heat and creating an extremely harsh working environment. Despite the laborious nature of the job, income for salt workers is often unstable, depending heavily on harvest volume and fluctuating market prices. Yet for those who have devoted their lives to it, salt farming is more than just a livelihood. It is a source of pride, deeply tied to the culture and traditions of coastal communities. For large-scale salt fields, mechanized harvesting is the optimal choice, boosting productivity while significantly reducing manual labor. Today, self-propelled salt harvesters, equipped with front blades and inclined conveyor systems, are among the most commonly used machines in modern salt production. These machines shorten collection time and improve transportation efficiency. Instead of serving merely as transport equipment like earlier models, modern self-propelled salt harvesters now integrate all key functions: scraping, collecting, and storing salt into a single machine. A front-mounted blade pushes the crystallized salt toward the center, where an auger conveyor lifts it into a rear storage compartment with a capacity of several tons. This type of machine is now widely used in large-scale salt fields across the United States, Australia, and several Middle Eastern countries, regions that demand high efficiency and advanced automation. Whether harvested by hand or machine, the salt is ultimately transported to storage areas where it is preserved before distribution. From there, it may be sold as coarse, raw salt or sent to refining facilities where it is processed into fine purified crystals, suitable for cooking and food manufacturing. At facilities dedicated to raw salt production, trucks loaded with salt from crystallization fields are driven directly to the material intake area. The salt is dumped into a receiving hopper connected to a conveyor system that transports it into the processing plant. Here, workers perform an initial visual inspection, removing visible impurities such as trash, seashells, stones, or other foreign objects mixed in with the salt. Next, the salt passes through a rotating crusher that breaks apart large clumps and loosens the material, ensuring more uniform grain size. The final stop is the packaging area, where the salt is measured into evenly portioned bags, then sealed using either heat sealing machines or industrial stitching to prevent moisture intrusion and allow for easier transportation. At this stage, the salt retains most of its natural minerals, making it ideal for food preservation, water treatment, or industrial uses such as chemical production, de-icing roads, and water softening. At refined salt processing plants, raw salt is first unloaded into a feed hopper, which connects directly to an automated conveyor system that carries it into the main production line. In the first stage, the salt is transferred into multi-stage washing tanks, where fresh water is used to remove fine sand, silt, dissolved impurities, and any remaining microorganisms. In some modern systems, the washing process is enhanced with vibrating screens and centrifugal separators, which help extract both heavy and light contaminants with maximum efficiency, without dissolving the valuable salt crystals. After the washing step, the salt is transferred into a tank or automatic dissolving unit to form a brine solution. Here, the salt is dissolved in hot water or a concentrated salt solution to reach a saturated state, meaning the highest possible salt concentration. The solution is continuously stirred to accelerate the dissolving process and improve efficiency. Next, the saturated brine solution is passed through a multi-stage filtration system to remove dissolved impurities such as calcium ions, magnesium, heavy metals, and any remaining insoluble residues. The filtration equipment may include settling tanks, pressure filters, sand filters, activated carbon filters, or the use of chemical precipitants like soda ash, NaCO3, or lime, CaOH2, to eliminate calcium and magnesium. To produce batches of pure white salt, the clean brine solution must be crystallized using a vacuum crystallization system or multi-effect evaporators, where temperature and pressure are tightly controlled. The evaporation of water under vacuum conditions causes the salt to recrystallize into fine, uniform granules. After crystallization, the wet salt crystals are sent through a centrifuge to remove excess moisture, producing semi-dry salt. This salt is then transferred to a hot air drying chamber, where the temperature is carefully controlled to fully dry the salt crystals without causing clumping or degradation. This drying process typically uses a fluidized bed dryer or a continuous belt dryer system. After drying, the salt may be cooled using air to prevent it from reabsorbing moisture when exposed to the external environment. Depending on its intended use, the salt is then ground into various particle sizes, such as fine salt, powdered salt, table salt, or industrial salt. Grinding and screening machines ensure uniformity and consistent quality of the final product. The salt crystals are separated into different sizes using vibrating screens or air classification, ensuring the final product meets uniformity and technical standards. Once refined, the salt is transported to an automated packaging line. This system can pack it into 500 grams or 1 kilogram consumer bags, as well as larger industrial sacks ranging from 25 kilograms to 50 kilograms. Each batch undergoes strict quality control checks, including moisture content, purity, iodine levels, and microbial presence. Products that meet the standards are stored and then distributed to the market. But you might wonder, what happens to all that water used in the process? Is it simply discarded? Not at all. In fact, modern salt refining plants are equipped with integrated wastewater treatment systems to ensure environmental safety. Wastewater from washing, filtering, and drying stages is treated using physical, chemical, or biological methods. Once purified, this water can be reused in non-food contact applications, such as cooling systems or equipment surface cleaning. This approach not only reduces operational costs, but also aligns with sustainable production standards. In addition to common sea salt, there are also rare and valuable types like Korean bamboo salt, which can cost many times more due to its unique mineral content and a painstaking production process that takes weeks or even months to complete. This unique type of salt originates from Korea and has been used in traditional medicine as a detoxifier and digestive aid. Bamboo salt begins with natural sea salt, but instead of being refined, it is packed into sections of fresh bamboo, which are then sealed at both ends with volcanic clay. These bamboo tubes filled with salt are fired in a kiln at extremely high temperatures, ranging from 800 degrees to over 1,300 degrees. And the process can be repeated 3 to 9 times depending on the grade of the salt. The first firing removes impurities, while subsequent firings enhance mineral content and trigger chemical reactions between the salt, bamboo, and clay. During the firing process, the salt changes color, from white to purple, gray, or metallic hues, and its crystal structure is transformed. It loses the harsh sharpness of regular salt and develops a more mellow taste with subtle mineral undertones. Remarkably, bamboo salt is highly alkaline, with a pH between 10 and 12, and is believed to neutralize excess acid in the body, aid in treating stomach ulcers, detoxify the liver, eliminate heavy metals, and cleanse the mouth. Compared to refined sea salt, which is primarily pure NaCl, bamboo salt is almost a controlled chemical transformation, crafted through traditional methods. Each batch can take several days to weeks to complete and consumes a large amount of raw material. Producing 1 kilogram of 9 times roasted bamboo salt may require over 10 kilograms of raw sea salt, along with meticulous labor. This explains why bamboo salt commands such a high price, especially the 9 times roasted variety, which can cost as much as $200, $300 per kilogram, and is often sold in small containers as a health supplement rather than used as a daily seasoning. Now imagine yourself standing in the middle of a sugarcane field that stretches all the way to the horizon, where towering, sturdy stalks reach up under the sun. Welcome to Brazil, the kingdom of sugarcane. Every year, this country grows over 700 million tons of sugarcane, more than anywhere else on Earth. But don't let the plant's humble appearance fool you. From this seemingly simple grass, humans have built a massive industry worth over 40 billion US dollars. And here's a sweet little fact you might not know. Just 10 sugarcane stalks are enough to produce a 1 kilogram bag of sugar. Compared to other crops like corn, wheat, or fruits, which contain less than 10% sugar, sugarcane stands out with a natural sugar content of up to 16%, making it one of the sweetest and most efficient raw materials for sugar production. And it all begins with the harvest season, when the sugarcane fields come alive, ready to kick off a brand new production cycle. Before the harvest season officially begins, farmers in many sugarcane growing regions choose to burn the fields. It might sound unusual, but the goal is to remove the dry leaves and unnecessary tops of the sugarcane. This practice helps clean the stalks, reducing the amount of unwanted material like fallen leaves, organic debris, and insects, which in turn makes the harvesting process quicker and more efficient. Plus, collecting only the sugar-rich stalks helps cut down on transportation costs. However, because this method produces a significant amount of smoke and harmful emissions, sugarcane burning is now strictly regulated. In some areas where it's still allowed, burning must follow specific timeframes and environmental conditions to minimize its impact on air quality and public health. In light of these concerns, harvesting fresh, unburned sugarcane using modern machinery is increasingly being encouraged and is quickly becoming the new standard. Sugarcane harvesters are engineered with high precision, capable of cutting close to the ground without damaging the roots, allowing the plant to regenerate for future harvests. As the machine moves along the rows, a system of sharp, continuously rotating blades slices the cane stalks cleanly. At the same time, the leaves and tops are removed directly on board, using a smart separation system combined with powerful fans. These unwanted parts are returned to the field, forming a natural mulch layer that helps retain soil moisture and boosts fertility. The valuable cane stalks, rich in sugar and economic value, are pre-processed on the spot, cut into short segments and sent to a large holding chamber at the back of the machine. A modern harvester can handle between 80 to 120 tons of sugarcane per hour, equivalent to the workload of dozens of manual laborers. This significantly speeds up the harvest process, cuts costs, and is especially well suited for large-scale sugarcane farms. Once full, the chopped cane is swiftly transferred to waiting trucks at the edge of the field, ready to be transported straight to the factory. This ensures the cane remains fresh and retains its optimal sugar content. After harvesting, millions of tons of sugarcane are transported to the factory by truck or train, depending on the region. The cane must be delivered to the mill as quickly as possible to prevent dehydration and loss of sweetness. Juice samples from different farms are collected separately and analyzed in on-site laboratories to determine the sugar content of each batch. Before processing begins, the sugarcane is passed through a high-pressure water spray system to be thoroughly washed. This step removes soil, sand, dust, and any remaining impurities clinging to the cane stalks, ensuring the raw material meets the necessary cleanliness standards. Thorough cleaning not only protects the crushing equipment from damage, but also plays a crucial role in preserving the quality of the raw sugarcane juice, the primary ingredient used to produce sugar. After being washed, the long sugarcane stalks are fed into specialized cutting machines to be chopped into smaller pieces. The stalks are cut into short segments to make them easier to feed into the crushing system. On its way to the crushing machine, each cane stalk passes through a set of interlocking metal gears that tear it apart. With a processing speed of up to 30 tons an hour, this system keeps the factory buzzing non-stop. If you still can't picture how much that is, one dairy cow would need around 40 days to chew through that much sugarcane, assuming she doesn't get bored and wander off halfway through. Next, these pieces pass through powerful crushers equipped with heavy rollers that continuously press and squeeze the cane to extract raw juice. Thanks to this roller system, the sugar content is extracted as efficiently as possible, maximizing the output of the entire process. Once the crushing is done, the leftover dry pulp, known as bagasse, is far from waste. Instead, it's smartly collected and reused. Meanwhile, the raw cane juice becomes the key ingredient for the next stages of refined sugar production. Have you ever experienced the scent of a mountain of sugarcane pulp filling the air? I bet it's one of the sweetest and most soothing smells that could ever make you feel truly satisfied in life. And now, prepare to be amazed by how factories make almost full use of sugarcane bagasse, turning it into eco-friendly products like plates, cups, and even paper. The bagasse is then collected and transported to specialized recycling facilities by truck or through a centralized transfer system. At the recycling plant, the bagasse goes through a high-pressure water washing system to remove impurities like soil, sand, shredded cane peel, and any remaining sugar. After washing, it is either mechanically pressed or lightly dried to prepare it for the grinding stage. Once cleaned, the bagasse is fed into grinding machines to break down its fibrous structure. The resulting mixture is then cooked at high temperatures, sometimes with a small amount of natural additives like starch or recycled paper pulp to enhance the material's stickiness and flexibility. The processed bagasse pulp is poured into pre-designed heated metal molds, shaped like plates, cups, bowls, or food containers. Here, the hot pressing process takes place at temperatures ranging from 160 to 200 degrees Celsius. Under the combined effect of heat and pressure, the pulp gradually hardens and takes the shape of the mold, while any remaining moisture is evaporated. As a result, the product not only forms a fixed shape, but also gains a stable, firm surface, ready for the next finishing steps. After molding, the semi-finished products go through a final drying stage to reduce moisture content to below 8%. Next comes the finishing stage, where excess edges are trimmed and the rims are smoothed to ensure both visual appeal and safe use. Finally, a water-resistant coating made from bio-based materials or plant-based wax is sprayed onto the surface, allowing the product to safely hold hot or liquid foods. The finished products undergo quality inspection and are then packaged using paper or cardboard materials to minimize environmental impact. From there, these bagasse-based plates, cups, and containers make their way to supermarkets, food stores, or restaurants. In reality, products made from sugarcane bagasse can biodegrade within 60 to 90 days and are considered a much more environmentally friendly option compared to plastic, which takes 500 to 1,000 years to decompose and is one of the biggest environmental challenges today. But the issue is, bagasse products require proper industrial composting conditions to decompose that quickly. If they are thrown into regular landfills, the decomposition time can sometimes be even longer. And now, let's dive into the most anticipated part, the sugar factory, where those sweet drops of sugarcane juice are transformed into the pure white sugar crystals we use every day. After crushing, the raw sugarcane juice still contains fine impurities like fibers, dust, and organic residue. To purify it, lime is added to the juice. The lime reacts with the impurities, causing them to precipitate out, making the juice clearer, a crucial step before concentration. Next, the juice enters a multi-effect evaporation system, typically made up of 3 to 5 connected evaporators. In this system, water is gradually removed by heating the juice at temperatures ranging from 70 to 150 degrees Celsius, depending on each stage and the pressure inside. Through this process, the juice thickens and turns into a pale yellow syrup with a noticeably denser consistency. This concentrated syrup sets the stage for the crystallization step, where sweet crystals begin to form from the thick golden liquid. To begin the crystallization process, seed sugar crystals are added to the concentrated syrup, which is then slowly cooled. Over several hours, sugar gradually begins to crystallize. The resulting mixture is then transferred to a centrifuge, which spins at high speed to separate the sugar crystals from the remaining molasses. This is the key step that defines the difference between raw brown sugar and refined white sugar, a question many people have long wondered about. Brown sugar retains about 3 to 5% of natural molasses, giving it a rich brown color and a distinctive caramel-like aroma, while white sugar is refined to the point that it contains up to 99.9% pure sucrose, resulting in its bright appearance and clean, pure sweetness. After centrifugation, the sugar crystals are still slightly moist, so they are sent into a drying system to remove all remaining moisture. This prevents clumping and extends shelf life. Once dried, the sugar is ready to move on to the refining stage, where it will be purified to achieve its final sparkling white form. To produce pure white sugar, a decolorization process is carried out. First, raw refined sugar is dissolved in hot water at around 80 degrees Celsius. The solution is then heated and filtered through layers of sand and gravel, followed by activated carbon columns to remove the color. Finally, the solution is centrifuged once more to obtain pure white sugar crystals. Once the pure white sugar crystals are obtained, they are cooled and fed into a fully automated packaging line within a sealed, hygienic environment. The first step is precise weighing. Electronic scales measure out exact portions based on preset weights. Next, the sugar is dispensed into preformed plastic bags. These bags are pulled continuously from large PE film rolls cut to size and sealed with heat. This process is incredibly fast. Dozens to hundreds of bags can be packed every minute. After sealing, the bags pass through a metal detector to ensure no foreign objects are present. Once approved, the bags are printed with expiration dates and traceability codes, then packed into large cardboard boxes for distribution to the market. Just like humans, a dairy moo's mood plays a crucial role in its productivity. When they're happy, lounging in lush green pastures without a care in the world, they produce rich, creamy milk that turns into the butter we love. However, when they're stressed, whether it's due to a poor diet, bad weather, or maybe just a grumpy farmer, their milk supply drops faster than butter melting on a hot pancake. Do you agree with these moos? Before a drop of milk is collected or a stick of butter is made, every dairy story begins in the vast farmlands, where lush green pastures stretch endlessly to the horizon, stepping into the harvesting process that ensures the highest quality nutrition for dairy cows. Equipped with sharp cutting mechanisms, modern forage harvesters swiftly trim lush green pastures. Inside the harvester, a powerful chopping unit reduces the grass into finely cut pieces, optimizing it for easy digestion and maximum nutrient absorption for dairy cows. As the harvester glides across the fields, freshly cut forage is immediately collected and transferred into specialized silage wagons running alongside. A single modern forage harvester can process hundreds of hectares per day, transforming vast fields of grass into tons of high-quality feed. Once harvested, truckloads of fresh forage are transported to silos or bunkers, where they undergo a careful fermentation process to create silage. Over several weeks, natural lactic acid bacteria ferment the sugars in the forage, gradually lowering the pH. This process preserves essential nutrients, resulting in high-quality silage that provides dairy cows with a stable, energy-rich diet year-round. Once the cows are fed a balanced diet, they grow and mature until they reach breeding age, typically around 15 to 18 months. Farmers carefully manage the breeding process, either through natural mating or artificial insemination, to ensure healthy pregnancies. After approximately 9 months of gestation, the cows give birth to calves, and once they recover from calving, they begin producing milk, officially entering the lactation phase. Before milking begins, cows are guided into a modern milking parlor, where they are kept in a calm and comfortable environment with soft lighting and optimal temperatures to reduce stress. After the udders of these happy cows have been thoroughly cleaned, farmers perform a pre-milking strip test to stimulate milk flow and ensure that every drop meets the highest quality standards. Next, the automated milking machine is carefully attached to the cow's udder. This system features vacuum-powered teat cups, mimicking a calf's natural suckling motion. A single cow produces an average of 30 to 35 liters of milk per day, while a large dairy farm can collect over 50,000 liters daily. Impressive, right? The fresh milk is immediately cooled to below 40 Celsius in refrigerated storage tanks, ensuring top quality. It is then collected by insulated milk trucks and transported to processing facilities, where it undergoes a magical transformation, becoming golden, creamy butter. After tens of thousands of liters of fresh milk are collected from happy cows and transported to the factory, the journey of transforming milk into butter officially begins. First, the milk undergoes a strict quality control process. Experts analyze fat content, freshness, pH levels, and bacterial presence to ensure that only the highest quality milk is used in butter production. Once the milk meets the required standards, it is transferred from storage tanks into the factory, where it needs to be gently warmed before cream separation. This process takes place in a heat exchanger system, where the milk is heated to approximately 30 to 40 Gracedruth to allow the fat to separate more easily from the skim milk. With this optimal temperature, the centrifugation process becomes more efficient, ensuring maximum cream extraction for butter production. Don't be mistaken, butter isn't made from whole milk. Instead, it comes primarily from rich cream. To extract this cream, the milk is sent through a high-speed centrifuge, spinning at over 7,000 revolutions per minute to separate the cream from skim milk. At this stage, the cream remains in liquid form, containing 35 to 40% butterfat, and this will be the key ingredient in producing those golden, creamy butter sticks. Before moving forward, the cream must be pasteurized to eliminate harmful bacteria while preserving its natural flavor. This is the most critical step in butter production. The cream is poured into industrial butter churns, where it is agitated continuously to break down the fat structure. At first, the cream thickens gradually, and then tiny butter granules begin to form and cluster together into soft, smooth butter. Meanwhile, the remaining liquid, known as buttermilk, is separated. After approximately 20 to 30 minutes of churning, the butter granules become more defined, and we can clearly see the distinct texture of freshly formed butter taking shape, our sticks that will eventually make their way to consumers' tables. Once the butter has formed, it is washed with cold water to remove any leftover buttermilk, extending its shelf life and preventing unwanted sourness. Specialized machines knead and blend the butter until it achieves a perfectly smooth and creamy texture, ready to be salted or flavored as needed. The water separated during the butter washing process will have a color like this. And this is truly the result after the butter has been thoroughly washed. It has a naturally pale yellow color, a smooth texture, and balanced moisture, making it soft and easy to shape. The washing process helps remove any remaining buttermilk, extending the butter's shelf life and enhancing its pure, rich flavor. When the butter reaches its ideal texture, fat content, and flavor, it is transferred into molding machines, where it is shaped into sticks, blocks, or large bulk portions, depending on its intended use. For household use, the butter is typically molded into convenient sticks or rectangular blocks, making it easy to measure and store. For commercial kitchens and bakeries, larger blocks are produced to accommodate high-volume cooking and baking needs. Meanwhile, bulk portions are prepared for industrial food production, where butter is used as a key ingredient in various processed foods. Throughout this process, the butter's consistency is maintained to ensure a smooth, uniform product that meets quality standards before packaging and distribution. The butter is then wrapped in foil or vacuum-sealed packaging to preserve its freshness. Automated production lines can package thousands of butter sticks per minute, ensuring high-speed production while maintaining top-quality standards. Before heading to consumers, the butter undergoes one last round of quality checks. Experts evaluate its smoothness, moisture content, color, and taste, ensuring that every stick meets the highest industry standards. Once approved, the freshly made butter is shipped to supermarkets, restaurants, and kitchens worldwide. But this fascinating journey doesn't end here. Do you know what happens to skim milk after it's separated from butter? After pasteurization, skim milk is sent to the packaging process for preservation and distribution to consumers. First, it is rapidly cooled to maintain its quality and freshness. Then, the milk is transferred to a sterile filling system, where it is packaged in cartons, plastic bottles, or specialized pouches to protect it from light and bacteria. The packaging process follows strict standards to ensure food safety. Each package is securely sealed before being labeled with detailed information, including nutritional content, production date, and expiration date. Did you know that in the US alone, 97% of households have at least one bottle of ketchup in their kitchen? Heinz, the giant of the ketchup world, ships out up to 650 million bottles annually, making the United States the largest ketchup producer in the world. All thanks to a secret recipe we'll uncover in this video. Is there a food you just can't enjoy without a splash of ketchup? Drop a comment below. We're betting burgers and fries might have something to say. Every August, tomato fields enter their busiest harvest season of the year. Harvesting tomatoes is surprisingly similar to picking perfectly ripe grapes. It must be done gently, but with great precision. As the machine rolls in, its front conveyor system slowly lowers, carefully sliding under the dense tomato vines. The ripe, red tomatoes are gently lifted to avoid any bruising or damage. Then the shaker system kicks in, creating steady vibrations just strong enough to detach the tomatoes from their stems without compromising their quality. At the same time, the rear fan system roars to life. A powerful but controlled gust of air blows away leaves and small branches, leaving behind only the plump, ripe tomatoes. Any green or damaged fruits are automatically pushed off the conveyor and dropped into a rejection zone. The vibrant red tomatoes continue flowing smoothly down the main conveyor belt, forming a river of crimson color. One modern machine can harvest up to 15 tons of tomatoes per hour, making the entire process remarkably fast and efficient. Incredible, isn't it? The selected tomatoes roll toward the end of the conveyor belt, where a mechanical arm extends from the machine's side. A cascade of tomatoes pours into a waiting trailer. One by one, the trailers fill up with juicy red tomatoes, ready for the next leg of the journey. The factory. Once harvested, thousands of fully loaded trucks rumble toward the processing plant, carrying mountains of ripe red tomatoes. At the factory, the tomato-filled trailers are emptied into massive bubbling water tanks. Gentle streams of air bubbles rise up through the water, softly massaging each tomato, helping to remove stems, dust, soil, and other surface debris. This process not only cleanses the tomatoes, but also protects their delicate skins, preserving their freshness and vibrant red color. After the initial soak, the tomatoes move onto a conveyor and pass through high-pressure water jets. These powerful sprays blast away any remaining dirt, ensuring each tomato is sparkling clean and ready for processing. With a processing capacity of up to 20 tons of tomatoes per hour, this step is both highly efficient and essential for maintaining product quality at the industrial scale needed for ketchup and tomato sauce production. The brilliant red tomatoes rush along the conveyor in steady waves, creating a living sea of red, ready to move into the next stage of transformation. Once washed, the tomatoes pass through an automatic sorting system. Color sensors and laser scanners detect and remove any bruised, rotten, or unripe tomatoes. Using either air jets or mechanical arms, the system pushes defective fruits off the conveyor. Meanwhile, factory workers provide a final inspection, ensuring that only perfectly red, ripe, and evenly sized tomatoes move on to the next phase. After being sorted, the tomatoes are sent into a steam blanching system at a temperature of approximately 85 to 90 degrees Celsius for nearly 1 minute. The hot steam softens the skin, making it easier to peel without losing the essential nutrients inside, while also preserving the fruit's natural color and flavor. Immediately afterward, the tomatoes are rapidly cooled with cold water to halt the ripening process and maintain their freshness. This cooling process also helps loosen the skin more effectively. Next, the tomatoes are transferred onto a conveyor belt equipped with specialized rollers that gently remove the skin without damaging the flesh, ensuring high quality for the subsequent processing stages. Once peeled, the tomatoes are sent into industrial grinders where they're transformed into a thick, smooth puree. Stainless steel blades spin at high speed, turning the fruit into a consistent, rich mixture. This puree then passes through a specialized filtering system that removes seeds, fibers, and pulp. What remains is a silky blend of tomato flesh and juice, the golden base for creating tomato sauce and ketchup. In the tomato sauce production process, the tomato pulp and juice extracted after grinding are transferred into large cooking tanks. The mixture is simmered at a temperature of 85 to 95 degrees Celsius for about 1 hour to deepen the flavor and evaporate excess moisture. Compared to ketchup, tomato sauce is cooked longer to preserve its natural texture and original taste. As the mixture begins to thicken, ingredients like olive oil, salt, sugar, minced garlic, and herbs are added to enhance the sauce's natural flavor profile. After going through the cooking, fine filtering, and seasoning adjustment process to achieve the perfect flavor, tomato sauce is immediately transferred to the sterile packaging area. Before coming into contact with the sauce, all glass bottles or tin cans must undergo a thorough cleaning process. Once the packaging is ready, the automatic filling system kicks into action. Thanks to smart dosing technology, each bottle or can is filled with a precisely measured amount of tomato sauce, ensuring consistency while preventing overfilling or shortage. After filling, the containers pass through a vacuum sealing machine. Removing all the air from the packaging helps prevent oxidation and limits the growth of microorganisms. Immediately afterward, the bottles or cans are sealed tightly using a heat press system or automatic capper. Even though the process so far has been rigorous, to guarantee absolute food safety, the sealed products are then sent to a high-temperature sterilization system. Finally, the delicious bottles of tomato sauce are neatly arranged and moved to cold storage rooms kept at temperatures between 4 to 10 degrees Celsius. Thanks to the cool and dry environment, the sauce can retain its full flavor, color, and quality for 6 to 12 months. Ready to serve everything from home-cooked meals to large-scale commercial kitchens. During ketchup production, the tomato pulp and juice are cooked at higher temperatures, but for a shorter time compared to tomato sauce, around 90 to 100 degrees Celsius for approximately 45 minutes. This method helps retain the ketchup's fresh and tangy flavor. Heinz's legendary status is often credited to its perfectly balanced recipe, said to its 72 to 75% concentrated tomatoes, 12% distilled vinegar, 10% natural cane sugar, and other natural ingredients. This combination creates the signature sweet tangy taste and velvety texture that's hard to beat. Once the cooking is complete, the ketchup is sent through a high-pressure homogenizer to achieve a perfectly smooth and uniform texture. After rapid cooling, Heinz ketchup enters its final stage, packaging. Plastic bottles are the most commonly used packaging format for Heinz. An automated precision filling system dispenses the ketchup into each bottle with high accuracy, ensuring consistent volume and quality across every unit. Next, a screw cap or flip-top lid with a protective seal is applied and tightly secured to preserve freshness and prevent air from entering. The bottles are then labeled and printed with the production and expiration dates using an automated labeling system. Thanks to this meticulous and hygienic packaging process, Heinz has continued to deliver consistent quality and its signature flavor, unchanged for more than 150 years. Imagine standing in the midst of vast mustard fields, with brilliant yellow mustard flowers stretching as far as the eye can see under the sun. Welcome to Saskatchewan, the golden land of Canada, where it produces up to 40% of the world's mustard supply, providing high-quality mustard seeds to the entire globe. But don't let these tiny seeds fool you. Every year, millions of tons of mustard seeds are harvested, contributing to an industry worth billions of dollars. And within those millions of mustard seeds, only the bright yellow and white seeds are chosen to create the legendary French's mustard, while the rich brown and black seeds are carefully selected to make the premium, sophisticated Dijon mustard. Unlike French's mustard, which offers a mild heat and subtle sweetness, perfect for fast foods like hot dogs and hamburgers, Dijon mustard stands out with its sharp flavor and smooth texture. Ideal for sophisticated dishes where refinement and complexity in taste are highly valued. What many don't realize is that mustard production tells an untold story much larger than just farming. Mustard season not only reflects the climate and soil, but also partly reveals the character and culture of each country. From the simplicity and strength of yellow mustard in the west of Canada and the US, to the refinement of Dijon mustard in France and the boldness and depth of brown mustard in Indian cuisine, each type of mustard carries the distinctive mark of its cultural and culinary heritage. Every legendary tale has a beginning, and when the once brilliant yellow fades, giving way to a warm brown velvet carpet, it's the sign that harvest season has officially arrived. The ripeness of the mustard seeds, with their vibrant color and protective outer shell, reveals the first secret in the journey of creating the exceptional flavor of mustard. That's when the steel beasts, massive combine harvesters, start rolling. With giant tracks or wheels, they move steadily across the fields, guiding their razor-sharp blades deep into the dry, brittle mustard stalks. Once inside, the entire plant passes through a powerful threshing chamber. Here, spinning rotors work non-stop, breaking the seed pods apart with intense impact. This process frees the tiny brownish-yellow mustard seeds, which fall onto a vibrating sieve below. Meanwhile, the remaining stalks are pushed out the back and scattered across the field as a natural mulch, helping retain moisture and nourish the soil for seasons to come. The sieving system now enters a more delicate phase. Precise vibrations shake off leftover dust, shells, and debris. Each machine has a capacity of up to thousands of tons of mustard per hour, equivalent to the labor of about 300 workers working continuously. While these machines enhance productivity and efficiency, their growing use raises several environmental concerns, including air pollution, dust, loss of biodiversity, noise pollution, and other negative impacts on the environment. Therefore, the adoption of sustainable solutions is becoming increasingly important to mitigate these impacts and ensure long-term, sustainable development for both the industry and the planet in the future. As the Symphony of Harvest comes to a close, fully loaded trucks begin to roll out, carrying this tiny yet mighty spice toward the next leg of its extraordinary journey, revealing the next marvelous secret, the transformation into the flavorful mustard we know and love. As soon as the trucks carrying thousands of tons of mustard seeds arrive at the factory, an automated robotic system takes samples directly from the containers and delivers them to the testing room. Before mustard seeds can become a flavorful condiment, they must go through a thorough cleaning and screening process. Not washing the mustard seeds with water is the next secret, as it helps reduce the risk of lowering seed quality, preventing them from becoming damp and affecting both storage and the seasoning production process. In the factory, the seeds are transported upward via conveyor belts into a feed hopper connected to a vibrating device, ensuring a steady flow into the sorting system. Next, the seeds enter a size sorting machine, where multi-layer vibrating screens separate out seeds that are too small or broken, keeping only those that meet the desired standards. After size sorting, the seed stream continues through a gravity separator, where hollow seeds or lighter impurities are removed by a strong air current. Finally, the mustard seeds pass through an optical sorting machine where defective or low-quality seeds are detected and removed using advanced image scanning technology, ensuring that only the highest quality seeds are retained for the next stage. Before stepping into the realms of the French's factories in the US, or the premium Dijon mustard production in France, let's explore how mustard oil is made in India, where the oil is not only an essential part of cuisine, but also a vital ingredient in billions of household kitchens. Here, the process begins with grinding brown mustard seeds, which are then fed into a heavy rotating press that separates the seeds into two parts: pure mustard oil and solid residue. To extract as much oil as possible, the residue is repeatedly processed and pressed until the last drops of oil are extracted, ensuring no oil is wasted. Finally, the oil, once separated, is filtered using natural methods such as cloth filtration or bentonite clay and other decolorizing agents, depending on the scale of production. Mustard oil contains significant amounts of erucic acid, a compound that can be harmful to health, particularly to the heart if consumed in excess. The result of this oil pressing process is mustard oil that is clear with a characteristic sharp and spicy flavor, stronger than sunflower oil. So if you ever have the chance to visit India and sample its traditional mustard oil, you might experience a genuine flavor that few places around the world can offer. After we have explored the rich tradition of mustard oil production in India, let's dive into the secret formula behind one of the most premium mustards in the world: the exquisite Dijon mustard, starting with the soaking and grinding stages. First, the mustard seeds used to produce Dijon must be either brown or black mustard, as these varieties have a sharp and robust flavor, adding refinement and complexity to Dijon mustard. In the initial stage, mustard seeds are poured into soaking drums equipped with a rotating mechanism and a continuous spray system. This system circulates clean water mixed with about 5 to 10% vinegar and 1 to 2% salt, which not only softens and hydrates the seeds, but also activates natural enzymes in their outer layer, kickstarting the release of essential oils and developing that signature pungent mustard flavor. After the seeds have been properly soaked, they move on to the grinding stage, a crucial key step that releases the essential oils, full flavor, and distinctive pungency. Especially popular in France, particularly in the Dijon region, traditional mustard stays loyal to the age-old method of slow granite stone grinding. The mechanism is simple yet effective. A heavy rotating stone slowly grinds the seeds against a fixed base, crushing them without generating significant heat. Each large stone mill can process about 15 to 20 kilograms of seeds per hour, ideal for small-scale, high-quality production. The main advantage of this method is that it maintains a low temperature throughout the grinding process, minimizing the evaporation of essential oils, the very compounds responsible for mustard's signature heat and aroma. This is the key to creating the sophisticated and refined flavor of Dijon mustard. After the mustard seeds have been ground, the next mixing process adds ingredients in precise proportions. Vinegar makes up about 5 to 10%, salt from 1 to 2%, sugar around 3 to 5%, and special spices such as wine or specific flavorings are added according to the mustard recipe, creating a balanced and distinctive flavor. Not stopping there, mustard undergoes a crucial fermentation process, lasting from 24 hours to 1 week, allowing the flavors to intensify and creating a perfect harmony between the spices. While Dijon mustard continues its fermentation process, the production of French's mustard will amaze you with its efficient and high-speed industrial methods, propelling it to become a beloved global favorite. Unlike Dijon mustard, the yellow and white mustard seeds, after being preliminarily cleaned and stored in the warehouse, are directly fed into high-capacity grinding machines. The grinding system uses high-speed steel shafts to break the hard outer shell and release essential oils. To preserve the flavor and reduce evaporation, the system is equipped with cooling units that maintain temperatures below 30 degrees Celsius. Each industrial mill can process 300 to 500 kilograms of seeds per hour, more than 20 times faster than traditional stone mills. Although industrial mustard may lose a bit of that artisanal soul, it delivers exceptional consistency, scalability, and speed, all crucial for meeting global demand in the modern food industry. Next comes the blending stage, the crucial step that defines the final flavor of the mustard. The freshly ground mustard mixture is believed to be combined with 70% water, 10% vinegar, 10% wine, 1 to 3% sugar and salt, along with turmeric powder and other spices. After blending, the mustard mixture is transferred into a maturing system where it rests to stabilize both flavor and texture. Compared to Dijon, the maturing process for French mustard is much shorter, lasting only from several hours to a few days. Next is the filtering and refining stage, where the mustard mixture is passed through pressure filters or ultrafine mesh screens to remove any unwanted residue. For certain premium mustard varieties, an additional settling process is used to achieve a smoother, silkier texture. Modern factories often use centrifugal filters, which rapidly separate out the solids without compromising the mustard's signature flavor. After completing the full processing and sterilization steps, the mustard is sent to the automated packaging area. Each type of packaging not only serves to preserve the mustard, but also reflects its market segment and the unique characteristics of each mustard variety. For popular American yellow mustards like French's or Heinz, often paired with hamburgers, hot dogs, or sandwiches, plastic packaging is the go-to choice. This type of packaging is favored for being lightweight, easy to transport, and user-friendly, perfect for everyday household use. For traditional mustards like Dijon or other premium varieties, glass jars are upgraded to a more sophisticated version, which is the glass jar. The glass bottling process requires extra care. Jars are first thoroughly washed and dried before entering a vacuum filling line, which helps prevent foaming and separation. Next, metal lids are sealed tightly and go through a leak detection stage to ensure each jar is perfectly airtight. Labels, often designed with a classic, elegant look, are applied to appeal to high-end consumers or for export markets. From here, premium mustard jars like Mai are distributed to global markets, especially in Europe, where they are priced 4 times higher than French's mustard. Today, mustard is more than just a condiment. It's a bold and iconic symbol of global culinary culture. Whether drizzled over a sizzling hot dog or slathered on a juicy burger, its signature sharpness has become deeply woven into the fabric of classic cuisine around the world. The first Saturday of August is celebrated as National Mustard Day, a tribute to the tiny seeds that have written a remarkable story and created a flavor loved in millions of meals across the globe. Imagine standing in the middle of vast, lush cucumber fields, bathed in sunlight, stretching endlessly to the horizon. Welcome to China, the king of agriculture, where over 77 million tons of cucumbers are harvested every year, accounting for up to 80% of global production. However, production alone is not everything. When it comes to pickles, the United States is the true king, with renowned brands like Vlasic, Mount Olive, Clausen, and a pickled cucumber industry worth billions of dollars, closely tied to the fast food boom. With their sharp, salty flavor and irresistible crunch, stand out as a refreshing contrast to other pickled products like brined olives or pickled beets, offering a distinctive tanginess along with the added benefits of probiotics that help support digestion and improve gut health. Among over 100 varieties of cucumbers, only a few have thin skin, few seeds, are crunchy, and absorb flavor well, making them suitable for pickling. However, even within that group, only the high-quality 5 to 8 centimeters gherkin cucumbers, out of millions, are selected to create the tangy, crunchy pickles that are the soul of millions of jars worldwide. This explains why gherkin pickles, with a history spanning over 4,000 years, continue to exist and have become the golden spice, beloved globally and playing an essential role in the food industry. And every legend has a starting point somewhere. For pickles, the iconic sidekick that has won over millions of food lovers around the world, that journey begins in the sun-drenched, green cucumber fields. From May to July each year, the cucumber fields become more vibrant than ever as the harvest season officially begins. On the vast fields stretching endlessly, modern machines, large, precise, and powerful, have become the extended arms of farmers during the busy season. As the machine moves along each row of cucumbers, the harvesting head functions like a giant comb, brushing through each stem and guiding the vines into the machine. Inside, an automatic sorting system removes unnecessary leaves and stems while only keeping the cucumbers that meet the standards and transferring them to the conveyor belt behind. Unlike the modern potato harvesting machines from Grimm or John Deere, which are designed to dig up soil and separate potatoes from the ground with a capacity of up to 20 tons per hour, Cucumber harvesting machines are built to be lighter and more precise, allowing them to harvest cucumbers without crushing the fruit, with a capacity of around 5 to 10 tons per hour. Traditional farming still yields stable cucumber harvests, but relies heavily on chemicals. In this context, organic farming, hydroponics, and greenhouses are gradually becoming the trend due to their ability to optimize yield, minimize negative environmental impacts, and address consumer concerns about pesticide residues and herbicides. Although technology has advanced significantly, it is the diligent hands of workers that still bring superior quality that machines cannot replace. Workers carefully pick each cucumber by hand, selecting those that are ripe and of the right size, then place them onto a moving conveyor belt attached to the harvesting machine or specialized trailer, helping transport the cucumbers to the storage containers quickly and gently. Manual harvesting, although much less efficient compared to modern machines with a capacity up to 15 times higher, ensures the finesse and precision that machines cannot achieve. After harvesting, trucks quickly transport the cucumbers to processing factories within 2 to 4 hours, preserving their freshness, crispness, and texture before embarking on the next secret journey, becoming the tangy, crunchy pickles that captivate the world. At the pickle processing plant, trucks carrying millions of tons of fresh cucumbers line up one after another, entering the raw material intake area. In modern factories, cucumbers are introduced into a closed-loop washing system, with multiple stages designed to ensure food safety and high input quality. First, cucumbers from transport trucks are poured into large indoor water tanks. These tanks contain clean, continuously recirculating water, often treated with ozone, diluted chlorine, or light brine to eliminate surface contaminants. The gentle water flow helps rinse off soil and debris while moving the cucumbers toward the conveyor belt without causing any bruising. Next, the cucumbers pass through a high-pressure multi-directional spray tunnel, typically 4 to 6 bar, where powerful water jets thoroughly remove dirt and bacteria. The water used in this stage is filtered and reused through a closed system involving mesh filters, activated carbon, and UV or ozone sterilization, ensuring both hygiene and resource efficiency. This process doesn't fully eliminate pesticide or chemical residues, which may remain on the fruit's surface. Therefore, to ensure consumer health and safety, factories must conduct strict checks in addition to following farming standards. Modern methods like HPLC and MS detect pesticide residues with high accuracy, with residue levels ranging from 0.05 mg to 5 mg per kilogram, depending on the pesticide and regulations. Now here's where it gets interesting. There are 2 popular methods, each with its own secret formula for making pickles: natural fermentation for traditional and premium lines, and quick vinegar pickling for industrial products. First, for the natural fermentation method, cucumbers are sorted and then placed into large fermentation tanks, often positioned outdoors to take advantage of the ambient temperature, providing ideal conditions for fermentation. This method not only saves energy, but also promotes the growth of beneficial bacteria, which in turn creates the characteristic sour taste and increases the probiotic content in the final product. Each tank is filled with brine solution, a mixture of salt water and spices like dill, garlic, pepper, bay leaves, and others depending on the unique recipe of each brand. The cucumbers are soaked in brine for 1 to 4 weeks, depending on the thickness of the skin, the type of product, and the desired flavor. It is the clever use of ambient temperature to promote the development of beneficial bacteria during fermentation, combined with the long soaking time, that is the key to creating the difference in flavor and crunchiness between the natural fermentation method and the quick vinegar pickling method. Once the fermentation period is complete, the pickles are carefully removed from the brine tanks and immediately transferred to the processing line for final cleaning and inspection. At this stage, each pickle is thoroughly rinsed to remove any excess brine, spices, or sediment that may have settled during fermentation. After rinsing, the pickles pass through a visual inspection system, either by trained workers or automated optical scanners, to detect and remove any defective or damaged pieces. Next, the pickles are sorted by size and shape using precision mechanical graders, ensuring uniformity in the final product. They are then transferred into filling machines, where they are packed into jars or food-grade barrels. Before sealing, each container is filled with a final brine solution, either the original fermented brine or a fresh one, prepared under sterile conditions, to maintain flavor and preservation. Finally, the sealed jars undergo pasteurization in hot water baths or steam chambers, depending on the product type and shelf life requirements. This step helps to stabilize the pickles, ensuring food safety while retaining their natural crunch and probiotic benefits as much as possible. In contrast, the vinegar pickling method takes only a few hours, meeting the enormous demand with billions of jars produced worldwide each year, and a longer shelf life, all while being about 4 times cheaper than naturally fermented products for the same volume. And this is why this method is so effective. After being thoroughly washed and sorted, the cucumbers are placed directly into pre-sterilized glass jars or plastic containers to ensure absolute hygiene. Before the cucumbers are added, dry spices such as dill, garlic, mustard seeds, black pepper, and bay leaves are added to infuse natural fragrance. The cucumbers are then automatically divided into the glass jars. In addition to whole pickles, many products are also sliced into rounds, cut into chunks, or shaped in various ways, perfect for topping McDonald's or Burger King's burgers, or served with salads and sandwiches at chains like Subway and KFC. After the cucumbers are divided into jars, they are moved to the brine filling area, where the soaking solution is added to complete the flavor and preservation structure of the product. The key difference in this step lies in one essential ingredient: vinegar. For industrial pickle products, due to the lack of natural fermentation time, the brine solution must include vinegar, acetic acid, at a ratio of 5 to 10%, combined with salt, sugar, and other spices. While the natural fermentation method requires refrigeration to maintain freshness and is typically consumed within a few months, vinegar provides an immediate sour taste. It also acts as a natural preservative, allowing the product to be stored at room temperature for up to a year or longer, making it more convenient for large-scale distribution in the global industry. For industrial pickle lines, this is also the beginning of the short fermentation process, which is strictly controlled for temperature and humidity, ensuring the product achieves a consistent flavor and standard crunchiness. So is naturally fermented pickled cucumber or quick vinegar pickled cucumber your idea of the perfect jar of pickles? The next step is pasteurization. Typically, the jars of pickles are placed in a continuous pasteurizer or high-pressure retort, where they are heated to a temperature between 80 degrees Celsius and 100 degrees Celsius for 10 to 30 minutes. After leaving the heat chamber, the product is rapidly cooled by passing through a cold water spray system, combined with high-powered fans placed along the conveyor belt, which helps quickly lower the temperature and prevent overheating or changes in the pickle's texture. Most naturally, fermented pickles don't require pasteurization, as the fermentation process creates an acidic environment that inhibits harmful bacteria and preserves beneficial probiotics. Finally, the jars of pickles are placed on a conveyor belt and pass through an automatic labeling system. Each label clearly displays the product name, ingredients, production date, and expiration date. This step ensures that all jars have consistent, accurate, and compliant information for distribution. Pickles not only play a vital role in the global economy, generating billions of dollars in revenue each year, but also serve as a cultural bridge, connecting diverse culinary traditions and bringing the distinctive sour flavor of 4,000 years of history to kitchens around the world. Imagine stepping into a vast avocado orchard where sun-drenched trees heavy with fruit stretch endlessly toward the horizon. Welcome to Michoacán, Mexico, the avocado capital of the world, where over 2.5 million tons are harvested each year. But Michoacán is just the beginning. The avocado boom has spread across other fertile regions, from the highland farms of Chile and the coastal valleys of Peru to the abundant groves of California, USA, forming a global avocado belt that powers both supply and export for the entire world. Although avocados may seem easy to grow, if you live in a region where temperatures drop below 5 degrees Celsius or rise above 38 degrees Celsius, your beloved avocado tree is almost certain to struggle or may not survive at all. Did you know? Avocados were once called alligator pears because of their bumpy skin. Unlike traditional sweet fruits like apples or pears, the avocado is a natural masterpiece. Rich in heart-healthy monounsaturated fats, packed with more potassium than bananas, and loaded with vitamins E, K, and C, along with lutein to support eye health. But the value of avocados goes far beyond nutrition. In Mexican culture, avocados and guacamole symbolize luck and abundance, with roots tracing back to the Aztecs. Today, guacamole is a global favorite, especially in the US, where it's a Super Bowl essential with thousands of tons consumed in a single day. Every remarkable journey has a beginning, and for avocados, it starts with the harvest season. By summer, after 6 to 7 months of careful development since flowering, avocado orchards grow heavy with fruit. Farmers work tirelessly, checking ripeness, preparing harvest baskets, and meticulously picking each avocado to ensure the best possible quality. A key factor that determines the fruit's perfect flavor and freshness lies in the farmer's sharp eye and intuitive touch, something no modern machine can replicate. Harvesting avocados requires finesse and a keen sense for selecting perfectly ripe fruit, smooth-skinned, unmarred, and just the right softness. Farmers use long poles with specialized cutters to reach high branches, often paired with sturdy ladders or mechanical lifts mounted on trucks. These mobile platforms allow them to adjust height and navigate between trees safely and efficiently. For lower-hanging fruit, the harvest is simpler. A gentle snip of the stem with shears or a skilled twist of the hand is all it takes. Each avocado is then carefully placed into a chest-worn basket to avoid bruising from impact. An experienced worker can harvest up to 450 kilograms of avocados per hour. Though modest compared to machine-harvested crops, this precision ensures the fruit remains fresh and flavorful, reflecting the care and respect farmers bring to each season. However, due to its biological nature, avocado farming demands a significant amount of water, about 320 liters for a single fruit. This raises sustainability concerns, especially in water-scarce regions like Mexico, Peru, and Chile. As climate change intensifies, The avocado industry is under increasing pressure to find more water-efficient and environmentally responsible farming methods. But harvesting is only half the secret behind the exceptional quality found in every avocado product. The other half lies beyond the orchard, deep within the walls of modern processing facilities. As soon as the avocados arrive at the factory, they undergo a strict incoming inspection process to ensure consistent quality across the entire batch. First, technical specialists randomly select samples from the avocado crates and examine them in a laboratory, assessing key indicators such as ripeness, firmness, color, and pesticide residue levels. Next, the crates of avocados are placed onto an inbound quality control conveyor belt. This conveyor system, equipped with continuously rotating rollers, allows workers to easily observe the entire surface of each avocado, enabling them to quickly identify and remove any fruits showing signs of bruising, cracking, or other defects. Only avocados that meet the highest quality standards are allowed to continue on to the next stages of processing, while substandard ones are immediately discarded. After passing the initial inspection, the avocados are transferred onto a conveyor equipped with high-pressure spray nozzles. The water pressure must be strong enough to remove dirt, sand, and debris, clinging tightly to the skin, yet gentle enough to avoid scratching the avocado's delicate outer layer, which bruises easily if handled improperly. However, rinsing with water alone is not enough to ensure complete cleanliness. That's why the avocados are then dropped into large water tanks containing a mild disinfectant solution. This step helps deeply cleanse every crevice of the fruit, wash away pesticide residues, lightly sanitize the surface, and quickly cool the avocados, all of which contribute to preserving freshness in the steps that follow. After the avocados are thoroughly washed and sanitized, they move on to the drying stage. Here, they are transferred onto a vibrating conveyor or an air-drying tunnel equipped with powerful, temperature-controlled fans. Proper drying is essential. It not only prevents water from interfering with downstream processes like cutting or peeling, but also reduces the risk of microbial growth during handling. Once dry, the avocados are ready for the next phase of processing. Next, the avocados are moved to the sorting area, one of the most critical steps in the entire process. But why is this so important? High-resolution industrial cameras combined with image analysis software automatically scan each avocado to assess factors such as size, skin color, and ripeness. Avocados that meet standards for shape, uniform color, and ideal or even underripe maturity are separated for fresh packing, domestic distribution, or export. Fruits that are moderately ripe, intact, and firm are directed into the frozen avocado processing line. Meanwhile, overripe or visually imperfect avocados, as long as the flesh remains high quality, are reserved for guacamole production. That's why the sorting system, which operates continuously with high precision, plays a crucial role in ensuring consistent quality across all product lines and maximizing the total value of every avocado batch. In the fresh avocado packing area, only the avocados that meet quality standards are sent directly onto the distribution conveyor. Here, workers perform one final quick check to remove any fruits that may have been damaged during internal transport. The avocados are then placed into specially designed trays or carton boxes, lined with soft padding to minimize impact. The packing process is primarily done by hand, allowing workers to use their flexibility and delicate touch to reduce surface bruising as much as possible. In some large-scale factories, automated robots are also used to speed up the packing process, though they often lack the finesse and gentleness of human hands. Each shipment is clearly labeled with information about its origin, packing date, and product type. The completed boxes of avocados are immediately placed in cold storage, maintained at a temperature of 5 to 7 degrees Celsius, to preserve peak freshness and quality before heading out to millions of consumers. Meanwhile, avocados that don't meet the standards for fresh export embark on a different yet equally fascinating journey, one that takes them through the frozen processing line or into the production of guacamole. At this stage, the avocados are fed into an automated cutting machine, where sharp rotating blades slice each fruit in half quickly and uniformly. After cutting, the pit is either removed automatically by the machine or manually by workers during the pulp extraction process. The avocado flesh is then transferred onto a chilled conveyor belt, where workers inspect each piece for quality, removing any bruised, damaged, or substandard portions. The approved avocado pieces continue on to the next stage of processing, while the low temperatures maintained throughout this step help preserve freshness and slow down oxidation. Avocado seeds may seem like waste left behind after each batch of guacamole, but in reality, they are far from useless. As microplastics are increasingly found in soil, water, and even human blood, bio-based alternatives are making a comeback and growing more popular than ever. First, the seeds are collected, thoroughly washed to remove any remaining pulp, and dried to reduce their moisture content to around 8 to 10%. Next, the dried seeds are finely ground into powder, then blended with natural binders such as cornstarch, bio-based glycerin, and organic additives to create a biopolymer mixture. This mixture is then molded using specialized machines to produce items like straws, spoons, forks, and plates, products that offer durability and heat resistance comparable to petroleum-based plastics, but with a major advantage: they can fully decompose within 180 days under industrial composting conditions. However, there's a catch. These eco-products are still 2 to 3 times more expensive than traditional plastics, and their fast biodegradability only occurs in strictly controlled industrial environments. If discarded carelessly into nature, they can actually take even longer to break down than conventional plastic. If you're searching for an oil that's both nutrient-rich and safe for your health, avocado oil is an excellent choice. It's produced by pressing or centrifuging the soft, ripe flesh of the avocado after the skin and seed have been removed. The extracted oil is then filtered to remove impurities while preserving its natural flavor and signature green hue. Compared to olive oil, avocado oil has a higher smoke point, a milder taste, and remains rich in healthy fats and vitamin E, making it ideal for both cooking and skincare. But the avocado's journey doesn't end there. With their rapid ripening and harvest volumes reaching tens of thousands of tons per season, avocados must be processed quickly, and freezing offers the most effective solution. Once the seeds and skins are removed, the pure avocado flesh is fed into an automatic slicer. Some products retain avocado halves or larger chunks without going through the cutting stage. After shaping, the avocado pieces are immediately transferred into an IQF system, where the temperature drops to -40 degrees within minutes. As a result, once thawed, the product retains much of its fresh taste and smooth, creamy texture, closely resembling that of a perfectly ripe avocado. But what happens when that 80% frozen green cube transforms into a creamy crowd favorite? This is where guacamole takes the throne, rich, vibrant, and ready to rule taste buds around the world. After a final quality check, the pulp is transferred into an industrial mashing machine. Depending on the product requirements, the avocado can be finely mashed into a smooth consistency or lightly mashed to retain small chunks of fruit. The mixing paddles operate at carefully controlled speeds and durations to ensure the desired consistency while preserving the fresh, vibrant flavor. Depending on the production line, the seasoning formula typically includes a precise blend of ingredients, often consisting of approximately 1.5% salt, 3 to 5% lime juice, 6 to 8% chopped onion, 5 to 7% diced tomato, and 1 to 2% chopped cilantro, based on the total weight of the mashed avocado. Once it passes quality checks, the guacamole is transferred to a sterile filling system for automated packaging. For retail or single-serve products, the guacamole is filled into shallow plastic trays or small round containers. After filling, the containers are sealed with plastic lids or covered with a thin, transparent film or foil seal, protecting the product from oxidation and ensuring maximum hygiene. Finally, the guacamole products undergo high-pressure processing, a cutting-edge, non-thermal preservation method. Subjected to extreme pressure, up to 6,000 bar, the guacamole is treated in a way that effectively eliminates harmful bacteria without the use of heat or chemical preservatives. This ensures the product retains its bright color, fresh taste, and natural texture, while significantly extending its shelf life. And perhaps, the next time you dip a nacho into guacamole, drizzle avocado oil over your meal, or sip from a biodegradable straw made from an avocado seed, you'll recognize that beneath that smooth green surface lies an entire world of innovation, sustainable agriculture, and human dedication. France is hailed as the wine capital of the world, the birthplace of timeless legends like Bordeaux and Champagne. Each year, the country produces over 4.5 million tons of wine, securing its place at the top of the global stage. Its vast vineyards are not only the soul of French agriculture, but also a treasury of culture, art, and culinary heritage. Wine defies the notion that intoxication can only be born from formulas repeated for millennia. Instead, nature has gifted the world with a unique marvel, ice wine, crafted from grapes frozen at 7 degrees Celsius. As the frost extracts the water, what remains is a rare, concentrated nectar of sweetness and purity, turning each glass into a vivid testament of harshness transformed into beauty. In the realm of luxury wine, as much as 20% is believed to be counterfeit, a figure even higher in the fine wine segment, including such illustrious names as Bordeaux and Burgundy. Yet many bottles still fetch millions at auction, only to remain sealed, for a single uncorking could shatter their value and expose the truth behind the glittering facade. And like every legend, that journey begins in sun-drenched vineyards, where each plump cluster of grapes is cherished as nature's treasure. As autumn arrives, a gentle breeze sweeps across the endless rows, while golden sunlight reveals the fullness of each grape. The moment that marks the start of harvest season, heralding the opening notes of an endless symphony of wine. For grape varieties used in table wines, mechanical harvesting is considered the optimal solution, boosting productivity while reducing labor costs. In countries with highly mechanized agriculture, such as the United States, especially California, which accounts for over 90% of the nation's grape production, most vineyards rely on advanced machinery for harvesting. These machines are equipped with soft vibration systems and precise sensors, creating gentle oscillations just strong enough to detach ripe clusters from the vine without damaging the fruit or the plant. As the grapes fall, they are caught by padded catchers lined with elastic material, then transferred smoothly onto conveyor belts. Thanks to this design, even the most delicate grapes retain their shape and quality. Each machine can harvest up to 9 tons of grapes per hour, many times faster than manual labor, while still preserving the freshness and flavor of the fruit. In long-established wine regions such as France, Italy, and Spain, where grapes are destined for fine wines or fresh consumption, human hands still play a crucial role in the harvest. This work demands precision and patience. Harvesters carefully walk row by row, using specialized shears to cut clusters at the perfect ripeness, then gently place them into soft baskets or cushioned crates to prevent bruising. Though time-consuming and labor-intensive, this traditional method offers an irreplaceable advantage. Each grape retains its shape, color, and flavor, meeting the most stringent standards for premium wines and high-end markets. And when the harvest season ends, it marks the beginning of a new and promising journey for these grapes. Before being transformed into refined bottles of wine, part of the grape harvest takes a different turn, one that is sweet and full of surprises. From sun-drenched clusters, the grapes quietly evolve into raisins, nature's candies, crystallized from light and time, preserving the pure essence of the earth and sky. Raisins are most often made through natural sun-drying, a process that seems simple, yet plays a crucial role in preserving their distinctive flavor. In major production hubs such as California, Turkey, and Iran, where the climate is hot and dry with abundant sunshine, grapes are spread out on cement floors, mats, or hanging racks for 2 to 3 weeks. During this time, the water inside the grapes slowly evaporates, leaving behind an increasingly concentrated natural sweetness. Some regions employ a special method, allowing grapes to dry directly on the vine before harvesting, producing raisins that are darker in color and richer in flavor. When the grape's moisture content drops to around 15 to 18%, the standard for commercial raisins, farmers collect them and send them to processing facilities for the next stage of post-harvest treatment. When the raisins arrive at the processing plant, the first step is preliminary screening. A vibrating system combined with suction fans removes dry leaves, stems, soil, and other large impurities. This is a crucial preparation stage before the raisins undergo more thorough washing. After screening, the raisins are cleaned using a high-pressure water spray system. Powerful water jets wash away all remaining dust and bacteria from the surface of the fruit. With a capacity of up to 10 tons per hour, this system ensures the washing process is fast and effective, without affecting the texture or natural flavor of the raisins. Once cleaned and carefully sorted, using both optical technology and skilled human inspection, the qualified raisins are transferred to a modern packaging line. Here, the raisins, after being thoroughly cleaned and sorted, are directly packed into large, sturdy cartons that ensure safety during storage and transportation. Thanks to a modern automated boxing system, the products are swiftly completed and made ready to be shipped worldwide, bringing their natural flavor to millions of consumers. And now comes the most anticipated moment, the journey of transforming luscious, fresh grapes into enchanting wine. From classic bottles steeped in memories to refined modern flavors, every secret behind the winemaking process will be unveiled, right here, right now. The story begins as massive trucks, loaded with freshly harvested ripe grapes, roll into the winery's receiving area. Here, the grapes are emptied into giant stainless steel tanks before being swiftly carried along a modern conveyor system, where speed and gentleness work hand in hand to preserve the fruit's quality to the fullest. A remarkable aspect of winemaking is that the grapes are never washed with water. On their skins lies a precious layer of natural yeast, essential to fermentation and responsible for the wine's unique character, something no technology could ever replace. Washing it away would strip the wine of both its flavor and its soul. Instead, the grapes are carefully cleaned by hand. Workers meticulously remove every stray leaf, stem, or damaged fruit, preserving the grape's natural living essence. Immediately after, they continue their journey along sorting conveyors, where sharp eyes and skilled hands examine each grape with precision. Any fruit that is bruised, discolored, or falls short of the standard size is discarded. Only the most flawless clusters are chosen to embark on the journey of becoming that legendary liquid we call wine. After being carefully selected, the grapes are passed through a specialized machine for the destemming process. This modern procedure uses advanced equipment to separate the stems from each cluster without damaging the fruit. Once freed from their stems, the grapes are gently moved on to the next stage. Following destemming, the grapes are sorted once again, this time by an optical system equipped with cameras and special lighting. Using image scanning and infrared technology, the system analyzes each individual grape with precision, automatically removing those that do not meet the required standards to ensure top-quality output. This technology can handle up to 20 tons of grapes per hour, streamlining production and improving efficiency. The carefully selected grapes then move into massive crushing machines, capable of processing up to 10,000 pounds per hour. Inside, finely engineered rollers and rotating paddles gently press the grapes, keeping the seeds intact, because if a seed were to break, bitterness would seep into the wine. After pressing, the grape juice is transferred into massive fermentation tanks, where the true magic of wine begins. Over the course of 10 to 30 days, natural yeasts quietly transform sugars into alcohol and carbon dioxide, causing the grape skins to rise and form a dense fermentation cap. To infuse the wine with rich color, aroma, and tannins, this cap must be regularly pushed back down, a rhythmic dance between human hands and nature. Once fermentation is complete, the wine undergoes clarification and separation to remove skins, seeds, and any remaining impurities. With the aid of specialized filtration systems, the pure wine gradually emerges, becoming clearer, brighter, and more refined. This step not only eliminates the risk of bitterness or off flavors, but also paves the way for the wine's character to fully develop. From here, the wine is transferred into aging vessels, ready to continue its journey toward becoming a legendary liquid. For fine red wines, after filtration, the wine is moved into oak barrels for aging, the place where the true miracle unfolds. Carefully pumped into the wooden casks, the wine will rest for anywhere from 12 months to over 2 years. During this time, the oak imparts its distinctive aromas while softening the natural tannins, resulting in a velvety structure and profound depth in every sip. At last, when the wine has reached its maturity, the most delicate journey begins: bottling. A wine bottle is not merely a container, but a home that defines its preservation and aging. The color, green, brown, or clear, is chosen to shield the wine from light, while the shape, Bordeaux, Burgundy, or Champagne, reflects both region and style. Then comes the closure, the traditional cork that allows subtle breathing, the modern screw cap that guarantees a tight seal, or, in the case of sparkling wines, a thick cork reinforced with a wire cage to withstand pressure. Throughout the process, oxygen control is paramount. Too much causes premature aging, too little suffocates the wine within. Finally, automated machines can fill up to 3,000 bottles per hour with milliliter precision before labeling, sealing, and sending this preserved flavor to every corner of the world. From sun-drenched vineyards to the shimmering glass on the table, the story of each drop of wine is a legacy of land, time, and tireless hands. Over thousands of years, this sweet fruit juice has transformed from ancient ritual to a modern emblem of refinement. And today, in a single sip, one can taste both tradition and innovation, intertwined in the most captivating way. Imagine standing in the heart of an endless sea of orange trees, stretching beyond the horizon. Welcome to São Paulo, Brazil. Brazil grows more oranges than any other country, over 17 million tons every year, nearly a third of the world's supply. But when it comes to turning those oranges into juice, the United States holds the crown, thanks to Tropicana. Today, Tropicana orange juice is enjoyed by millions around the world, with over 1 billion bottles produced each year, all thanks to a secret recipe that has been carefully guarded for decades, which we're about to uncover in this video. Bursting with vitamin C, orange juice contains twice as much as apple juice and nearly 3 times more than grape juice, turning your morning glass into a daily dose of sunshine and health. Like every great story, this one begins at the source, with the season's first ripe oranges, gently hand-picked from the orchard, revealing the very first secret in this magical process. Every year in November, the endless orange groves enter their most vibrant and bustling harvest season. Oranges must reach just the right level of ripeness, with firm, plump skins and a bright orange hue, before they can be picked to ensure the highest quality. At large-scale farms, harvesting machines operate in a highly systematic way. Soft brushes or vibrating rods move along each row of trees, calibrated to generate just the right amount of shaking, depending on the thickness of the branches and the ripeness of the fruit. Beneath the trees, a synchronized conveyor system quickly and continuously gathers the falling oranges, minimizing bruising and ensuring no ripe fruit is left behind. Meanwhile, in orchards where trees grow more naturally without neat rows, tree-shaking machines are the more common choice. The mechanical arms of these machines clamp onto the tree trunks and create powerful vibrations, causing all the ripe oranges to fall onto large tarps spread out beneath the trees. These modern systems can harvest up to 100 tons of oranges per day with remarkable speed and efficiency, especially ideal for orchards that are neatly pruned and organized in straight rows. However, as the saying goes, haste makes waste. Harvesting quickly with machines can damage the peel and the tree itself, while unripe oranges also get caught in the process. Perhaps even the orange trees wish for gentler treatment. That's why, on smaller farms, hand-picking remains the preferred method. Workers use specialized clippers to carefully harvest each orange, checking its ripeness right there in the orchard before gently placing it into baskets or mesh crates to avoid bruising. In the US, the job of picking oranges, rain or shine, is mostly done by immigrant laborers, earning about $1 per box. Strange as it may sound, these days it seems that an orange has an easier time immigrating to America than people from Mexico and many other countries. Once the baskets are full, the oranges are loaded onto small trucks and transported to a central storage area. And now, let's follow these oranges as they enter a world of high-tech processing, inside the orange juice factory, where secrets that have been closely guarded for decades are finally about to be revealed. As soon as the crates filled with plump, ripe oranges arrive at the factory, they're moved onto a conveyor belt fitted with rotating rollers. This roller system allows workers to examine each orange from multiple angles, identifying any that are bruised, rotten, or below standard size. Oranges that don't meet the requirements are immediately removed to ensure only high-quality fruit advances to the next stages of processing. Once the oranges pass quality control, they proceed to the cleaning area. Here, they're placed into large water tanks equipped with air bubble systems and sanitizing solutions that remove dust, pesticide residue, and any other impurities clinging to the peel. After this initial soak, the oranges roll through high-pressure spray nozzles for a final rinse, ensuring the surface is perfectly clean before entering the processing line. They are then moved to the drying conveyor. Powerful fans, working alongside rollers covered with soft bristles or special brushes, gently dry the oranges without damaging their delicate outer skin. In another part of the process, a modern factory setup will leave you amazed with its state-of-the-art machinery and impressive efficiency. Next comes sorting, a step that might seem simple, but is actually one of the most crucial links in the chain of producing a high-quality bottle of Tropicana orange juice. Only oranges that are perfectly ripe, full of juice, and have a flawless sweet-to-tart ratio are selected. A modern conveyor system equipped with sensors and automated cameras handles the sorting process based on size, color, and surface quality. The oranges first pass over adjustable slots that separate them by size. Smaller than standard fruit falls to a lower level for separate processing, while larger ones continue down the main line. In addition to the automated systems, trained workers are positioned along the conveyor to perform a final inspection, catching any flawed oranges the machines might miss. After this stage, the sorted fruit is directed to the appropriate processing or packaging area according to its quality. This meticulous sorting process ensures that only the best oranges make it into every bottle of juice. By combining advanced technology with human expertise, the factory maintains consistent flavor, color, and quality in every batch. The mixture of orange peel, sugar, and lemon juice is cooked in steam kettles or large copper pots at a temperature of around 104 and 108 degrees Celsius until it reaches the ideal thick, jam-like consistency. Once the ideal consistency is reached, the marmalade is poured into glass jars or plastic containers using an automated filling system on the production line. This filling process takes place in a sterile environment to ensure each container is filled with the exact amount of marmalade and remains uncontaminated. Lids are sealed, either screwed or pressed on, and labeled with full product details, including ingredients and expiration date. Sensors on the conveyor verify that each label is properly aligned and undamaged. After labeling, the jars go through a final quality check before being packed into cardboard boxes, sealed, and prepared for distribution. And now we arrive at the star of the show, the process behind the creation of those world-famous bottles of fresh orange juice. Once sorted, the oranges are sent into a modern mechanical juicing system, where they are pressed whole. No slicing required. Rotary drums or high-pressure presses compress each fruit, extracting the maximum amount of juice. This closed-loop system not only maximizes juice yield but also preserves the fresh flavor and natural nutrients, ensuring top-tier quality in every drop. Once extracted and filtered, the fresh orange juice is sent through a rapid pasteurization process, typically by briefly heating it to 85 to 90 degrees Celsius, and then quickly cooling it down. After pasteurization, the juice is poured into large specialized drums, usually ranging from 180 to 200 liters in capacity, and immediately stored in cold rooms at temperatures between 0 and 4 degrees Celsius. Afterward, the juice undergoes a thorough and multi-step quality inspection process to ensure it meets the highest standards of safety, purity, and flavor. Laboratory technicians collect samples from each batch to test for microbial content, pH levels, sugar concentration, and vitamin retention. Advanced analytical equipment is used to detect any possible contaminants or inconsistencies. At the same time, trained sensory panels may evaluate the taste, aroma, and color to ensure the juice maintains its signature freshness and balance. Storing the juice in these large batches helps maintain its quality and makes it easier to handle bulk distribution or prepare for final packaging later on. The entire bottling process is conducted in a sealed, sterile environment to prevent bacterial contamination and preserve product integrity. Before filling, empty containers, typically PET plastic bottles, glass bottles, or aseptic cartons, are thoroughly cleaned and dried with sterile hot air. The juice is precisely dispensed into the containers using volumetric sensor-controlled nozzles. Immediately afterward, the bottles are sealed tightly and passed through a tunnel pasteurizer using steam or hot water, which provides an extra layer of sterilization around the bottle's mouth and cap. This not only kills any remaining microorganisms, but also stabilizes the internal pressure to prevent the bottles from deforming during storage. Once pasteurized, the bottles are quickly cooled using cold mist sprays or immersion in chilled water baths. They then continue down the production line for final quality checks. Bottles that pass inspection are labeled, packed into boxes, stacked on pallets, and transferred into refrigerated storage, ready to be shipped to markets around the world. From a small basement in the town of Hershey, Pennsylvania, Harry Burnett Reese, a former farmer with nothing but a bold dream, created the Penny Cup, a chocolate and peanut butter candy that cost just 1 cent. That tiny treat quickly won over America and went global after a historic merger with Hershey in 1963. Today, inside Hershey's modern factories, Reese's shares the floor with other iconic creations like the Hershey Bar and Hershey's Kisses. But its place is irreplaceable. Over 4 million Reese's are produced every single day, generating more than $3 billion in annual revenue. Compared to the intense sweetness of Snickers or the crispy snap of Kit Kat, Reese's wins hearts with its smooth and unique texture. Soft chocolate melting into rich, perfectly balanced peanut butter, touched with just a hint of salt. It's a combination that fuels millions of cravings every single day. Now, join me as we step inside Hershey's massive factory, where that magic happens every minute, every second. First, let's start with the legendary peanut butter filling, the heart that made Reese's an icon in the world of candy. The main ingredient is high-quality runner peanuts sourced from the southeastern states of the U.S., marking the beginning of their journey from humble nut to signature peanut butter. In the first step, the peanuts are fed into a high-speed vibrating sieve system, operating at 300 to 500 vibrations per minute. This continuous shaking action effectively removes dust, shell fragments, and impurities with near-perfect precision, leaving behind clean, pristine peanuts, ready to enter their next phase of transformation. Immediately after, the peanuts are transported via an automated conveyor to a shelling machine. Using steady air pressure between 5 to 8 bar, the outer shells are gently removed. A high-powered suction system then whisks away the loosened shells, leaving behind intact, perfectly round peanut kernels. After being cleaned and shelled, the peanuts move on to a state-of-the-art optical sorting machine. Equipped with high-speed sensors and cameras, this system scans up to 5,000 peanuts per minute, detecting and precisely removing cracked, damaged, or substandard nuts using air jets accurate to the millisecond, leaving only the most flawless kernels. But the inspection doesn't stop there. Right after the automated filtering, a team of skilled workers manually checks the peanuts by eye. With sharp attention and swift hands, they sift through each kernel, removing any that are flat, broken, or below standard. The selected peanuts are placed into a rotating drum equipped with high-pressure spray nozzles, where powerful water jets remove dust, soil, and any remaining impurities. Once the peanuts are fully cleaned, they begin a remarkable transformation inside massive industrial roasters. The golden key to unlocking the signature flavor that only Reese's can deliver. The temperature is carefully maintained between 160 and 177 degrees for 25 to 30 minutes, just enough to thoroughly dry the nuts, create a light, crisp outer layer, and release their natural, rich aroma. After being perfectly roasted, the peanuts are quickly cooled and transferred to an air blast system that removes the thin, papery skins. This process reveals the golden kernels beneath, while also eliminating the bitter-tasting peanut hearts, ensuring that only evenly roasted, unburnt, and flavorful peanuts move forward in the process. Once perfectly roasted and stripped of their skins and bitter cores, the peanuts are fed into a two-stage grinding system, where the signature smooth texture of Reese's filling begins to take shape. In the first stage, the peanuts are ground into a thick, coarse paste. But the real magic happens next. This mixture passes through a high-tech ultrafine grinder, producing a silky, velvety peanut butter with a rich, dense consistency, free of grit, oil separation, or dryness. Alongside the peanut butter filling process, the outer chocolate layer, that rich, glossy brown coat, is prepared with just as much precision. The journey of Reese's chocolate begins with premium cacao beans, carefully sourced from renowned growing regions like Côte d'Ivoire, Ghana, and parts of South America. After being thoroughly cleaned, the cacao beans are sent into industrial roasters, where temperature and timing are strictly controlled to unlock their signature aroma. Each batch follows a custom roasting profile, depending on its origin and moisture content, to bring out the fullest range of natural flavors, from subtle woody notes and smokiness to delicate hints of berries. Once they reach the ideal roast level, the beans are quickly cooled to preserve their aroma, then cracked open to extract the inner cores, known as nibs. These are the most essential part of the bean, containing both cocoa solids and natural cocoa butter. The nibs are then ground in high-powered machines to produce chocolate liquor, a thick, flowing mixture that contains no alcohol but is rich in pure cacao flavor. This essence forms the foundation of Reese's signature chocolate, smooth, mellow, and crafted to pair perfectly with its iconic peanut butter filling. Next, the chocolate liquor is transferred into a sealed mixing tank, where it's blended with cocoa butter, sugar, milk powder, and lecithin, according to Reese's proprietary formula. This process takes place under tightly controlled conditions to create a smooth, consistent chocolate mixture. Unlike traditional dark chocolate, which can be intense, or milk chocolate, which is often overly sweet, Reese's chocolate is crafted to be gently sweet, smoothly textured, and moderately rich, just enough to enhance the peanut butter without overpowering it. This delicate balance is what gives Reese's its unmistakable character. Next comes the conching stage, a critical step in chocolate production, where the mixture is continuously mixed and aerated for several hours at temperatures between 130 and 180 degrees Fahrenheit, 54 to 82 degrees Celsius. This process further refines the cocoa and sugar particles, creating a smooth, uniform texture while also removing volatile compounds like acids and unwanted bitter notes. The result? Reese's chocolate becomes silky and velvety, melting gently on the tongue without harshness or astringency, delivering a perfectly smooth tasting experience. This is the soft secret behind the quality of Reese's chocolate, and it's also why premium chocolates are typically conched longer to achieve that luxurious texture and lingering finish. Finally comes tempering, the process of stabilizing cocoa butter crystals through controlled heating and cooling. The liquid chocolate is first heated to around 45 to 49 degrees Celsius to break down unstable crystals, then cooled to about 27 to 29. Without this step, the chocolate is prone to blooming, a whitish haze, becoming too soft or snapping unevenly when bitten. Thanks to advanced tempering systems, Reese's chocolate achieves a glossy finish, a light, satisfying snap when bitten, and the perfect melt-on-the-tongue texture. Once tempered to perfection, the chocolate is held at a stable melted state, ready for molding and pairing with its iconic peanut butter center, creating the sweet symbol that's conquered candy lovers worldwide. Once the peanut butter filling and outer chocolate are ready, they're brought to the most crucial part of the entire production line, the molding station, where each Reese's cup officially takes shape. First, the iconic paper cups, an unmistakable signature of Reese's, are neatly placed into metal trays. These aren't just wrappers, they act as molds, shaping every candy to perfection. Next, a layer of melted chocolate is dispensed into the bottom of each cup. The automated pouring system ensures every cup gets the exact amount of chocolate, with a smooth, even surface free of air bubbles. Immediately after, the warm, velvety peanut butter filling is precisely injected into the center. This is the heart of Reese's, and every drop must be perfectly centered to create a balanced bite. A second layer of chocolate is then poured on top, forming the lid of the cup. The molds are gently vibrated to eliminate any remaining air pockets, ensuring flawless adhesion between the layers with no cracks or separation once cooled. Finally, the trays move into a rapid cooling chamber, where the temperature is perfectly calibrated to solidify the chocolate within minutes. After leaving the cooling chamber, each Reese's cup is fully formed, with a glossy chocolate shell perfectly encasing the rich, creamy peanut butter filling inside. Next comes the final, yet equally vital stage, packaging, where each candy transforms from a factory product into a sweet icon, ready to hit the shelves. From there, countless Reese's cups are loaded onto refrigerated trucks and sent across distribution routes nationwide, reaching consumers through supermarkets, convenience stores, movie theaters, and even school lunchboxes enjoyed by millions of students. But every time you enjoy that sweet, irresistible treat, if you're a peanut butter fan, have you ever wondered, where does peanut butter come from? The origin of that smooth, creamy filling isn't a lab formula or a trade secret. It begins in vast peanut fields, where each nut is carefully planted, nurtured, and harvested, marking the very first step in the journey to becoming the heart of every Reese's cup. As the first cool breezes of autumn sweep across the southern fields of Alabama, farmers here gear up for their most important season of the year, peanut harvest. Mornings are filled with the scent of damp soil and the low rumble of machinery warming up. After a long summer of growth, the peanut plants stand ready, prepared to begin their journey from field to factory. In the fields, digger-shaker machines roar to life. With each plunge of their blades into the soil, rows of peanut plants are lifted and flipped upside down, exposing the golden pods to direct sunlight. In just a few hours, dozens of acres can be efficiently turned, far faster than manual labor ever could. Instead of artificial drying, farmers here let the peanuts rest right where they're flipped, drying under the autumn sun for 3 to 5 days. This gentle, even drying helps preserve the peanuts' natural flavor and color, without the need for energy-intensive equipment. Once the moisture level is just right, combine harvesters step in. Their rotating fans and sieves gently separate the peanuts from their vines, and the leftover stems aren't discarded. Instead, they're returned to the soil as natural mulch, enriching the ground for next season's crop and reducing fertilizer use. The peanuts are then loaded onto conveyors and dropped into giant holding bins, each carrying up to 10 tons. At nearby collection points, heavy-duty trucks transport the harvest to modern processing facilities, where temperature and humidity are carefully monitored. From here, the journey to becoming rich, creamy peanut butter begins, soon to be nestled inside the iconic Reese's cups, beloved around the world. Few would guess that a mishap in a popcorn factory in 1940 would mark the beginning of the Cheetos empire. During a test run of an extrusion machine, engineers accidentally created strange, puffed corn sticks, light, airy, and incredibly crunchy. But the biggest twist came from Richard Montañez, a Mexican janitor who boldly sprinkled chili powder on the snacks, giving birth to flamin' hot Cheetos. That daring idea didn't just skyrocket sales, it propelled him from the guardroom to the executive ranks of Frito-Lay. Mention Cheetos, and you can't ignore Chester Cheetah, the ultra-cool sunglasses-wearing cheetah draped in blazing orange cheese. Few know that when Chester debuted in the 1980s, he was initially rejected for being too rebellious and not child-friendly. But it was precisely that wild, rule-breaking persona that helped Cheetos break through, just like a cheetah smashing limits in seconds. Cheetos aren't just cheesy, crunchy snacks. They might even save your life in the wild. Thanks to their airy texture and high oil content, they ignite like dry kindling, making them perfect for starting fires and keeping warm in emergency survival situations. To fully understand the intricate journey behind every crispy Cheetos stick, we must begin at the very source, the special corn seeds planted into the soil, ready for a high-tech transformation powered by sun and soil. Across the vast fields of the American Midwest, a region blessed with dry, sunny weather ideal for starch-rich crops, giant John Deere tractors lead a fleet of precision farming machines. Modern multi-row planters move across the land, simultaneously opening furrows, dropping seeds, applying fertilizer, and covering the soil, all in a single pass. The seeds they sow are a specific type of hard yellow corn, a hybrid variety developed exclusively for Cheetos. These kernels are high in starch, low in moisture, and extremely dense, properties that ensure they puff up perfectly and deliver that signature crunch during extrusion. With annual demand reaching over 100,000 tons, every step from planting to harvest is strictly monitored to guarantee uniform quality and non-GMO compliance. From the moment the seed meets the soil to the crispy snack in your hand, it all starts here. Straight rows of corn, planted with surgical precision, now begin their life cycle, fueled by a critical element: water. On fields reserved exclusively for Cheetos-grade corn, massive center pivot irrigation systems, stretching hundreds of meters long, rotate like giant compasses, distributing water evenly from nearby channels. Pumping up to 2,000 liters per minute, each droplet is regulated by soil moisture sensors to maintain optimal hydration. Because just a little too much or too little water each day could affect the kernel's density and structure, key factors that determine the perfect puff and crunch of every future Cheetos stick. And then, by around July, when the corn silks begin to dry up and the fields turn a golden hue, it's nature's signal that months of careful cultivation are entering the harvest season. The exciting first step in transforming corn into crispy Cheetos. Unlike sweet corn or canned corn, which are valued for their intact ears, the corn used to make Cheetos is selected based on entirely different criteria. What matters isn't the shape, but the kernel's hardness, starch content, and how well it puffs during extrusion, the key to that signature Cheetos crunch. That's why mechanical harvesting is the ideal choice. Fast, efficient, and capable of handling hundreds of hectares in just a few days. Harvesters glide smoothly across the corn rows, using sharp, rotary or serrated blades to cut the stalks close to the ground. The entire plant is drawn into the machine, where counter-rotating augers take over, stripping off the outer leaves, isolating the high-quality ears, and moving them via conveyor into storage bins or directly into transport trucks. Meanwhile, the leftover stalks, husks, and leaves are blown out the back by high-powered fans, falling back onto the field as natural mulch or raw material for composting. A high-capacity harvester can process up to 15 to 20 tons of corn per hour, equal to the output of more than 100 manual laborers working non-stop. And beyond speed, the machine minimizes bruising, preserving the kernel's structural integrity and ensuring maximum freshness. After harvest, the corn is loaded onto large transport trucks, each carrying around 25 tons, and immediately hauled to nearby processing facilities to ensure the kernels remain as fresh and high quality as when they left the field. Before we step into the processing plant, let's pass through the farms, where a semi-manual harvesting method is still in use. Workers walk along the corn rows, skillfully snapping each ear by hand and placing them onto a conveyor belt attached to a trailing tractor. By selecting directly in the field, only ears at the ideal ripeness are picked, ensuring more uniform kernels, a key factor for perfect puffing and crunch in the final product. It's a blend of sharp human judgment and mechanical power, delivering both quality and efficiency. If full mechanical harvesting is like an electric razor clearing a face in seconds, then the semi-manual method is more like a meticulous barber, shaping every detail to perfection. Both methods serve the making of Cheetos, but depending on the farming conditions, corn variety, and technical requirements, each farm chooses the harvesting style that suits them best. As soon as the corn-filled trucks arrive from the fields, their cargo is unloaded into a staging area and fed onto underground conveyor belts. From there, an inclined belt lifts the corn upward and quickly transfers it into the pre-processing zone inside the factory. Here, workers collaborate with automated sensor systems to inspect the incoming corn. Any ears that show signs of pests, bruising, or fail to meet quality standards are rejected. Only those that meet strict criteria for freshness, size, and color are allowed to proceed, ensuring consistent quality for the entire production batch. After passing the inspection stage, the qualified corn ears are fed into an automatic husking machine, where husks and silks are neatly removed within seconds. The machine uses a system of rotating rollers combined with high-speed cutting blades, all controlled by sensors to maintain consistent cutting force, strong enough to strip away the outer layers, yet gentle enough to leave the kernels intact. Each machine can process between 3,000 to 5,000 ears of corn per hour, far surpassing the output of any manual labor team. All removed husks and silks are collected and sent to a recycling or composting area, where they're decomposed under controlled temperature and humidity conditions, with the help of microbial additives to accelerate natural breakdown. Immediately after, the corn is transferred into a high-pressure washing chamber, where hundreds of clean water jets spray continuously from multiple angles to flush away dirt and impurities. In the Cheetos production process, once husked and trimmed, the qualified corn ears are fed into a specialized kernel removal machine. This equipment uses a system of rotating blades and compression rollers to separate the kernels from the cob quickly and precisely. Unlike canned corn, where the kernel's shape must remain intact, corn for Cheetos is selected for its uniformity, hardness, and high starch content, crucial qualities for the grinding and extrusion stages that follow. The golden corn kernels are then passed through a continuous washing system, where clean water sprays from multiple angles, combined with vibrating belts to remove leftover husk fragments, light kernels, dust, and any remaining impurities from the separation process. Amazingly, the amount of water used to wash corn in a single day could fill an entire mid-sized swimming pool. But in modern factories, a closed-loop system recycles up to 80% of that water, cutting waste while maintaining strict hygiene standards. After being thoroughly washed, the corn is transferred into a drying chamber set at around 60 to 80 degrees Celsius. This drying process reduces the moisture content to an ideal level, ensuring the kernels are evenly dried, mold-free, and perfectly prepared for the next step, grinding, an essential stage in the making of Cheetos. Once dried, the kernels are fed into an industrial milling system. Inside, high-speed steel rollers crush the corn into a coarse powder known as cornmeal. For Cheetos, the cornmeal must reach just the right consistency, fine enough to ensure ideal expansion during extrusion, creating that signature light and airy crunch that sets Cheetos apart from everything else. Now that the golden corn kernels are fully prepped, the transformation into crispy Cheetos officially begins. Many people assume Cheetos are just another type of popcorn, crunchy and corn-based. But in reality, crafting Cheetos is a far more complex process, starting with precisely refined cornmeal. From the silo, the cornmeal flows through pipes into automatic weighing hoppers, where each batch is measured with pinpoint accuracy and its moisture content is carefully regulated. Starting at around 10%, the moisture level is increased to 15 to 20% by adding water in precise proportions. The mixture is then fed into a large rotary drum for thorough blending, preparing it for the extrusion stage, where the real transformation begins. The extruder is heated to 280 degrees Celsius, and its internal screw spins at high speed, generating intense friction and heat that turns the cornmeal into a thick, pliable dough. Under pressure reaching up to 300 psi, the mixture is forced through a shaping die and instantly puffs the moment it hits the open air, forming the very first shape of a Cheeto. Unlike regular molding, extrusion doesn't just shape the product, it transforms it. The combination of heat and pressure fundamentally alters the corn's structure, allowing it to expand into Cheetos' signature light, crispy, and airy texture. To achieve that iconic crispy texture, the puffed corn pieces are sent into a massive oven towering up to 12 feet high. Operating at around 350 degrees Fahrenheit, the oven bakes the product for about 4 minutes. Inside, the snacks rotate through multiple stacked tiers, like a spiral staircase, ensuring every surface is evenly dried and perfectly crisped. After baking, the puffed corn pieces enter a rotating flavor drum. Here, rice oil is blended with real aged cheddar cheese powder, heated and stirred into a smooth, velvety mixture. This cheesy blend is sprayed from one end of the drum, while the snacks tumble through a 25-foot-long rotating chamber, coating each piece evenly in that bold, signature Cheetos cheese flavor. It's in that final spin where the secret cheese formula is added, the very recipe that has the world hooked on Cheetos without ever realizing why. After completion, the Cheetos are sent through an automated packaging system, where they're weighed, sorted, and sealed into individual bags. With modern technology, each factory can produce thousands of pounds of Cheetos per hour, amounting to thousands of tons of crispy snacks each year. From the classic original to the legendary Flamin' Hot, over 50 different flavors are packaged and rotated depending on the region. Each bag doesn't just hold a snack. It carries its own cheesy cultural identity from one country to another. Imagine standing beneath a persimmon tree in autumn, where vibrant orange fruits sway gently in the soft sunlight. Welcome to Japan, the capital of wind-dried persimmons, where over 16,000 tons of dried persimmons are produced each year using a blend of traditional craftsmanship and modern technology. Here, wind-dried persimmons are more than just a delicacy. They are a cultural symbol, a refined winter gift cherished in every household and ceremony. A surprising fact, the white frost coating on the persimmon isn't mold. It's actually crystallized natural glucose, formed as the fruit dries. This sugary bloom is a mark of quality. The whiter it is, the sweeter and rarer the fruit, and the higher its value. Though sweet and delightful, persimmons can become a natural enemy of milk, especially when eaten on an empty stomach or by those with sensitive digestion. This combination can lead to indigestion, and in some cases even form intestinal blockages if consumed carelessly. From a beloved autumn treat to a real-life forbidden fruit, persimmons are both delicious and deserving of proper understanding. Every October, as the first chilly winds of the season arrive, persimmon orchards begin to glow with vibrant shades of orange and red, signaling the official start of the harvest season. At this time, the fruits grow larger and heavier, weighing down the twisted, brittle branches and prompting farmers to enter the busiest period of the year. To prevent the ripe persimmons from falling prematurely, farmers often set up bamboo poles or wooden supports beneath the canopy, tying the branches with ropes to keep the trees from breaking under strong winds. To harvest the fruit, farmers typically use specialized pruning shears, regardless of whether the persimmons grow low or high on the tree. Even for fruits within arm's reach, they still use the shears to carefully cut the stems, preserving the intact stem and avoiding scratches on the delicate skin. For clusters hanging high in the canopy, the task requires even greater precision. The picker extends the shears up to 3 to 6 meters, aligns them carefully, and makes a clean cut. Afterwards, all the harvested persimmons are gently placed into padded baskets to prevent bruising or surface damage. With towering persimmon trees that are several decades old, the harvest becomes significantly more challenging. Clusters of fruit hanging 6 to 7 meters high require farmers to climb trees or use ladders, skillfully maneuvering long-handled shears to reach each one. Every movement must be precise, both to ensure the picker's safety and to avoid scratching the fruit, as even a small bruise can ruin an entire batch of wind-dried persimmons later on. Once harvested, the plump, ripe persimmons are neatly arranged onto transport carts, ready to begin the next stage of their journey. The first stop for the freshly harvested persimmons is the wind-dried persimmon processing facility, where their transformation begins, from rough, raw fruit into chewy, sweet delicacies sought after around the world. Not all persimmons are suitable for drying. Only the large, astringent varieties with firm skins and high tannin content can endure weeks of hanging without falling apart. That's why the final sorting process at the facility is carried out with utmost care and precision. Freshly harvested persimmons are highly susceptible to softening, spoilage, or early fermentation if exposed to high temperatures or excessive humidity. For this reason, immediately after sorting, the fruits are moved into cold storage rooms, kept at around 1.5 degrees Celsius, just cold enough to preserve their freshness and slow down the natural ripening process. Once ready, each persimmon enters the peeling line, a process that may seem simple, but plays a crucial role in determining the appearance and final quality of the product. First, any excess leaves and small branches around the stem are trimmed off by automated cutters to prepare the fruit for peeling. Each persimmon is then firmly secured on a rotating spindle, while a set of sharp blades glides around its surface in a spiral motion, swiftly and precisely removing the thin outer skin without damaging the tender flesh inside. With a processing capacity of 1,000 to 1,200 fruits per hour, this system boosts productivity by more than 10 times compared to manual peeling, ensuring uniformity and reducing labor demands. However, no matter how fast these steel arms work, they still can't replace the human touch. Before hanging, workers carefully inspect each fruit by hand, trimming away any leftover rough edges that machines may have missed, because even the slightest flaw can compromise the quality of an entire batch. Ever wondered why every part of the persimmon is peeled except for the stem? That stem is far from useless. It's the anchor that allows the fruit to be suspended during the drying process, where the magic of sweetness truly begins. After peeling, each persimmon is carefully tied by its remaining stem and hung on a drying line. Skilled workers use nylon or specialized cords, deftly threading them through the stem and securing each knot to ensure that the fruit hangs 20 to 30 centimeters above the ground, without tilting or touching one another. This spacing is essential for even drying and to prevent mold growth. Depending on the scale of the facility, each line may hold 10 to 20 fruits. In some places, persimmons are hooked individually onto metal racks. In others, they are strung in symmetrical pairs for easier transport and better airflow during the drying process. Though this step may seem simple, it requires great consistency and precision. A single loose knot can cause an entire string, potentially worth thousands of dollars, to fall, damaging or ruining the entire batch. The wind drying process typically lasts between 30 and 60 days, depending on the persimmon variety, humidity, and regional climate. During this time, the fruit doesn't simply dry out, it undergoes a deep internal transformation. At regular intervals, each persimmon must be gently massaged by hand. This helps break down tough internal fibers, accelerates the transition from firm to chewy, and encourages the even distribution of natural sugars. More than just a technical step, this is a way for artisans to communicate with each fruit, shaping its soft texture and deep, mellow sweetness, characteristic of premium dried persimmons. Suspended in a clean, well-ventilated environment away from direct sunlight, the persimmons gradually lose moisture. Their natural sugars concentrate and crystallize on the surface, forming a fine white powder, the hallmark of a perfectly dried batch. As the fruit dehydrates, bitter tannins are broken down, allowing the sweetness to come forward. Through a mild natural fermentation process, the persimmon transforms, from astringent to delicately sweet, from firm to tender, a complete metamorphosis in flavor and texture. After being removed from the drying racks, the persimmons are laid out on a breathable surface to rest. At this stage, each fruit is gently rolled or pressed to redistribute the natural sugars inside. This helps create a uniform, tender texture and encourages the formation of the fine white sugar coating on the surface. Once they reach the ideal level of dryness, the persimmons are carefully arranged in traditional wooden boxes or sterile trays, ready for the final stage, packaging and distribution. If wind-dried persimmons are a slow transformation through air and time, then semi-dried persimmons take a different path. Faster, more controlled, powered by heat and technology. After sorting, the persimmons are peeled, with both the stem and core removed, then passed through a specialized cutting machine. Here, each fruit goes through a star-shaped blade, a unique slicing mold, that quickly divides it into even, bite-sized segments. This method not only shortens the processing time, but also produces uniformly shaped pieces that are easy to pack and perfect for ready-to-eat consumption. Before drying, the slices are neatly arranged on mesh trays to maximize heat circulation and prevent them from sticking together. Dozens of trays are then loaded into industrial drying chambers, where temperature and humidity are precisely controlled, typically kept at 50 degrees Celsius for over 20 hours. No sunlight, no wind, everything is managed by machines to ensure each slice dries evenly, remains soft and chewy, and retains its vibrant orange color. It's the industrial version of wind drying, faster and more compact, yet still requiring precision at every step. After drying, the persimmon slices are manually sorted under standardized lighting to remove any that are curled, undersized, or uneven in color. Only slices that meet strict standards for texture and color are transferred to an automatic weighing conveyor, which accurately portions each batch. The slices are then packed into multi-layer laminated pouches designed to block moisture and light, allowing long-term storage without the need for additives. Before sealing, a small amount of nitrogen gas is injected into each pouch to prevent oxidation and preserve freshness. The pouches are then heat sealed to ensure an airtight and secure closure. Cactus, the desert warriors clad in sharp spines, seemingly built just to survive, are quietly operating as profit-generating machines in barren lands, raking in hundreds of millions of dollars from their tough pads and juicy prickly pears. But have you ever wondered how millions of tons of cactus are harvested and processed every year? Under the scorching sun, with temperatures soaring above 40 degrees Celsius, where the land cracks open and the winds feel like fire, cactus plants proudly rise from the rocky, arid soil. When harvest season arrives, thick, fleshy pads and water-laden prickly pears are gathered and transported directly to processing facilities. There, through modern production lines, they're transformed into bottles of juice or even liquor. Today, join Agriculture Insight as we uncover the fascinating journey of cactus, from a dust-covered outcast to a desert superfood. All will be revealed in this video. Welcome to Mexico, the homeland of the cactus, where this spiny plant is regarded as one of the nation's strategic crops, leading the world in production with hundreds of thousands of tons harvested each year. More than just an enduring cultural symbol, the cactus serves as a vital source of food, industrial materials, and livelihood for millions. The prickly pear industry alone brings in over 100 million USD annually for Mexico. Beneath its thorny skin lies a sweet, refreshing flesh with a flavor blend of watermelon, pear, and kiwi, rich in vitamin C, packed with minerals low in sugar, making it ideal for diabetics and earning its place among the world's most promising superfruits. Thanks to its drought resistance, ease of cultivation, and high economic value, the prickly pear is increasingly seen as a key to the future of sustainable agriculture. So, where does this journey begin? Join us as we explore the land where blazing sun and rocky soil give rise to the remarkable survival story of the cactus. Everything begins with a step that may seem simple, yet it is a critical phase for anyone hoping to achieve a bountiful harvest: seed selection. In the semi-arid regions of Mexico, where scorching heat is part of daily life, choosing the right variety is never left to chance. Farmers carefully observe the mother plants from previous seasons, looking for cactus bushes that grow vigorously, resist pests, have thick pads, and bear sweet fruit. From these, they select mature pads that are aged but not yet woody. These pads are then detached and left to dry for a few days, allowing the cut to seal and reducing the risk of rot before replanting. Unlike most crops, cactus nopal isn't propagated by seed, but through vegetative reproduction. From a single juicy pad, a whole new generation can emerge. This isn't just a traditional method, it's how people have learned to be patient, to understand the soil and the plant, and to quietly sow into dry earth a belief that life will return. Once the planting pads are ready, farmers move on to the next crucial step: preparing the soil, the foundation that will nurture an entire new generation under the sun and wind. Although cactus is renowned for its drought tolerance, the soil still needs to be plowed 20 to 30 centimeters deep to break up compacted layers and allow young roots to spread freely. Next, aged manure, typically from cows or chickens, is added to enrich the soil and help retain moisture. In areas with acidic or saline soils, rice straw ash and lime are used to balance the pH. They don't try to force fertility into the land. Instead, they simply create conditions that are just enough. Enough for the plant to anchor, enough for the roots to find water when drought strikes. Because in that restraint lies resilience, the kind that allows new life to take root and grow stronger. Once the soil has been thoroughly tilled and the planting pads have been dried just enough to seal the cut ends, preventing rot while preserving vitality, farmers begin the planting process. Each pad is placed at an angle of about 60 degrees, buried 5 to 10 centimeters deep in the loosened soil. This depth is just enough to secure the base while allowing young roots to easily anchor and grow steadily. As the pads settle into the earth and begin to awaken life within, growers resist the urge to water immediately. For the first 2 weeks, the soil is left dry, encouraging the roots to stretch deeper in search of moisture hidden in lower layers, a natural response that helps the plant establish a stronger foothold in harsh environments. Only when new shoots begin to emerge, those first subtle signs of life, does irrigation begin. Water is applied sparingly, just enough to moisten the soil without making the plant dependent on external sources. With cactus, it's not about how much water is given, but when it arrives, a perfectly timed nudge that tells the young plant it is ready to thrive in a dry and demanding world. When the dry season lingers long enough and the sun has scorched the edges of each cactus pad to a golden hue, the prickly pears begin to ripen, changing from green to amber, then to deep red, swollen as if they've gathered the desert sunlight beneath their delicate skins. This marks the start of the first harvest, a task that must be done gently yet cautiously, as these fruits are both fragile and covered in nearly invisible hair-like spines. Harvesting usually takes place in the early morning when the sun is already casting its light across the desert. Farmers dress in long sleeves, gloves, and wide-brimmed hats to shield themselves, carefully stepping between rows of spiny plants. Using steel tongs or curved knives, they skillfully twist each fruit, detaching it from the pad with a light motion, taking care not to tear the thin skin or release the ultra-fine spines that can lodge deep in the skin and cause hours of irritation. Each fruit, once picked, is gently dropped into bamboo baskets or plastic tubs kept nearby, making it easy to move through the rows while minimizing handling and contact. Once the last prickly pears have been gathered, farmers return to a familiar rhythm, harvesting the nopal pads, the tender green stems often referred to as the lungs of the cactus. What seems like a simple task actually demands great precision, as even a slight miscut can damage the mother plant and disrupt its entire growth cycle. The selected pads must not be too old or woody. Their surface should still be smooth, evenly thick, and tinged with that signature jade green. With a razor-sharp knife, the worker makes a swift yet delicate cut close to the base, carefully avoiding the bud eyes. Tiny growth points where even a small scratch can prevent new shoots from sprouting. Every cut must be clean, exact, as if the cutter understands the biological rhythm pulsing beneath those layers of spines. Roughly every 7 to 10 days, new pads emerge, and the cycle repeats, like a steady breath across the desert landscape. At larger farms, semi-automated machines are now used for harvesting, reaching speeds of 500 to 700 kilograms per hour, resembling combine harvesters in arid terrain. Yet, not every field is flat, and not every cactus grows in neat rows. In rugged hillsides where the earth cracks like dried skin and plants grow wild, each cut is still entrusted to human hands, where technique, intuition, and years of experience preserve something no machine can replicate: the art of cutting to keep life alive. Immediately after harvest, both cactus pads and fruits are carefully stacked into ventilated plastic crates and quickly transported to the processing facility. The transport must be completed within the same day to prevent sun exposure from dehydrating the produce or causing the sap to ferment, since just a few hours under the heat can significantly alter the quality. For such perishable crops, speed and gentle handling are critical to preserving freshness. At the processing facility, crates are unloaded by hand or with small forklifts and neatly arranged into batches in the staging area. The space is cool, sheltered, and has clean flooring, helping to reduce temperature shock as the produce transitions from intense sun to shade. Each pad is then manually sorted, rinsed with cold water, gently despined, and left to drain for about 30 minutes. Pads that meet quality standards are packed according to their destination: whole pads for restaurants, sliced portions for supermarkets. Every package is labeled with traceability information and stored in cold rooms at 4 to 8 degrees Celsius, cool enough to preserve the vibrant green color, yet mild enough to retain the pad's natural flavor. Nopal pads that don't meet commercial standards are set aside for a different purpose, becoming a green source of nutrition for livestock, especially cattle and buffalo during the dry season. After being washed and despined, the pads are fed into specialized shredders, where they are either sliced into 2 to 4 centimeter strips or ground into a soft, wet mash that's easy to digest. At larger farms, chopped straw, sugarcane pulp, or dried grass is often mixed in to balance nutrients and increase roughage. Modern machines can process 1 to 1.5 tons of cactus pads per hour, an impressive output considering that in many semi-arid regions, this is the main source of feed keeping livestock alive through the dry season. With a water content of up to 90% and rich in potassium, calcium, and natural mucilage, Nopal helps animals stay hydrated, improves digestion, and reduces heat stress. In sun-scorched areas where even grass withers, Nopal becomes a living water tank for livestock, quietly feeding and hydrating herds without a single drop of rain. After a short journey from field to facility, the prickly pears rest quietly in crates, as if returning from a harsh expedition. Their skins remain plump and vibrant, yet are coated in dust and lined with fine spines, so delicate that a single touch might release an invisible cloud of needles, sharp as the desert's thoughts. To cleanse this natural armor, the fruits pass through soft brushes, rotating slowly under cool water, where each spine falls away like the last grain of sand slipping from the hand of the wind. Water pressure, rotation speed, the tilt of the conveyor belt, everything is calibrated not just by machines, but by experience. For the skin of the prickly pear is as fragile as the final breath of ripeness on the surface of fruit. On large farms, a single machine can process 400 to 600 kilograms of fruit per hour. Yet speed is never prioritized over precision, because even the smallest scratch can begin the fruit's decline within hours. Once the dust and fine spines have been removed, the prickly pears move on to their final stage, packaging. Workers select the fruit using both sight and experience, not just to pick the most attractive ones, but to ensure perfect ripeness and firmness. Fruits that meet the standard are carefully arranged in ventilated trays or mesh bags, labeled with their origin and packing date as a promise of quality. Finally, they are placed in cold storage at 8 to 10 degrees Celsius to preserve their freshness and flavor all the way to the consumer's hands. In addition to daily fresh consumption, a significant portion of prickly pears is sent to processing plants, where the ripe, succulent fruits continue their transformation into a variety of high-value products. After being peeled, either manually or using semi-automated machines, the fruits are deseeded and fed into cold press extractors. With a capacity of 500 to 800 kilograms of raw fruit per hour, these systems can handle dozens of tons each day while preserving the purity of the juice. The result is a vibrant pink-orange liquid, glowing with a natural radiance, as if infused with the essence of dry soil, scorching winds, and late-season rains. This isn't just juice, it's a nutrient-rich concentrate, packed with vitamin C, flavonoids, and especially betalains, powerful antioxidants with anti-inflammatory properties up to 3 times stronger than those found in beets. Though not every drop of cactus juice ends its journey as a refreshing drink, some are reserved for a quieter transformation into wine. In cold steel tanks, the vibrant pink-orange liquid undergoes natural fermentation over 7 to 10 days, guided by probiotics and steady temperatures. Once the wine has matured, it is filtered and left to rest, gradually turning into a clear ruby-red hue. A single sip reveals a delicate sweetness that touches the tip of the tongue, carrying the essence of dry earth, blazing sun, and the art of finding pleasure amid harshness. From edible pads to juice, from fresh fruit to fermented wine, the cactus proves that even the most rugged things can reveal gentle beauty when respected and understood. This journey isn't just the story of a plant, but a testament to resilience and adaptation, lessons both nature and humanity are relearning in an increasingly arid and changing world.